Excellent. All right. Welcome, everyone. Good morning. My name is Adrian. So we've got a jam-packed session for today. We are so excited to have you guys all here. So I'm just going to get things going. I've also got wonderful Jiamin from UBS. Jia, if you want to say a quick hi.
Hello, everyone. I'm in Sydney right now.
Oh,
Yep.
okay. Fantastic. I've got a quick slide over here on Zoom etiquette. I'm sure you guys are all comfortable with this because we have been doing this for quite some time and many of the schools have been online as well. Just make sure that you are on mute unless you have a specific reason to speak to. I'd really appreciate it if you guys can, at least a few of you can have your cameras on. It just provides me some feedback when I'm going through the content. And if you're not quite understanding something, if you squint or tilt your head, that'll give me an indication that I'd have to repeat myself or go over the questions again. But I'm hoping everyone's comfortable with this stuff. If you do have any tech related questions, just put it in the chat. We've got our tech viz Andrew with us today, so he'll help us out with that. Before we kick things off, I'd like to acknowledge the traditional custodians of the land that we're gathered on. I pay my respects to the elders, past and present, for they hold the memories, the traditions, the cultures, and hopes for Aboriginal and Torres Strait Islander peoples across the nation. I'm very grateful to be in Australia and to benefit and contribute to this amazing country. So over here we've got the agenda for Further Maths. Now the way I've broken things down is I've looked at, as you know, for Further, you've got the two core, the compulsory components that you have to do, which consist of data and statistics, and you've also got the recursion and financial maths component. Unfortunately, because students would have been doing various different modules, I have excluded the matrices, linear, trigonometry, or networks component for today. But at the end of this session, if you do complete the survey, what I'll do is I'll make sure I've added all of those files for you as well, so you can go and watch them. You can download them and have a go at them. Excellent. So the first half of the day before our lunch break, I'm going to focus on all the data and statistics questions. So hopefully you guys have got your calculators all charged up and ready to go. It's going to be packed. I've essentially looked at different concepts, and then we're going to have a look at 2 or 3 exam questions relevant to each of these concepts. Okay, so it's a strategy to try and incrementally bump up your scores. If you make sure you are 100% on one of these topics, that could mean that you have 3% covered on the exam. So we're sort of incrementally working towards getting that perfect score. Fantastic. Just a little bit about me. So I'm a Skyline alumni myself. I graduated in 2011, so many years ago. My hair does not look like that anymore because I've had to do my haircuts by myself lately. So it's almost like I never left school, because straight after graduating from high school, I started my own tutoring company. And over the last 9 years, I've been doing tutoring, about 20 hours of tutoring per week. At the moment, I'm tutoring about 130 students on a weekly basis. I'm also working full-time for the Faculty of Business and Law at Deakin University. So you might come across me in some of the recruitment-related events. Other than that, I'm extremely passionate about teaching and learning mathematics. So hopefully you guys will engage during the day today and ask all your questions. Please use the chat function so I can assist you in whichever way possible. Fantastic. So to kick things off, guys, we've got types of data, right? So we know that we're always going to have a types of data related question. When it comes to this concept, it's important to note that we've got 2 types of data. So we've got the categorical as well as numerical. And categorical breaks down into nominal as well as ordinal, and numerical breaks down into discrete and continuous. Now, to differentiate between a lot of the the questions where people get stumped on is where they struggle to identify whether it's a nominal variable or a numerical variable, right? So, an ordinal variable or a numerical variable. For example, if I was to say postcode, can I get you guys to use the chat function and let me know what sort of a variable you think a postcode would be? It's nominal, great. Because if you think about it, although there's an order when it comes to postcode, so you could have 3174, 3175, the order does not really give us an indication as to a quantity or a rank, right? It doesn't mean that 3175 is better than 3174, right? So I've got some notes here. Think, does it make sense to find the average? First of all, would we find the average of everyone in this group here and say, well, on average, students in this group is from 3175.63. We wouldn't say that, right? It doesn't make sense to do that. So that's one way to identify whether it's a numerical variable. And if you know that it is a numerical variable, countables are going to be discrete. Continuous would be anything that you can measure. With regards to categorical, how about phone numbers then? What about mobile phone numbers? What would you say that is? You can use the chat function again. Yeah, nominal again, right? So although the numbers would generally be generated in order, the numbers doesn't really, give you a rank or a quantity. Okay, so I've got some notes there. Feel free to annotate the content yourself if you've got a Surface Book or an iPad that you can write on. And we're going to go right into some questions. So let's have a look at this question here. So with each of these, what I'm going to do is I'm going to look at a few questions from each of the topics. So we've got a types of data question, and they're asking us to find the number of discrete numerical variables. So when we say discrete numerical, we know these are things that we count, right? Distance. We've got distance is measured. So we've got this is a categorical. We've got this is continuous. We've got number of children. Now that is something that we would count, right? Types of car. So this is once again numbers, but they're categorizing them, aren't they? And postcode, again, that's going to be a nominal variable. Okay, so how many have we got? We've just got the one where we're counting, so that will be the number of children. Okay, the number of ordinal variables in this data set. So ordinal is where you've got a quantity or rank against it. Are there any ordinal variables in this question? I'd get you guys to give me the response on the chat, please. How many ordinal variables are in this data set? Come on, don't be shy. None, right? How is it none? Because we know, although this is a nominal, although this is a categorical variable, we already know that it's a nominal. Excellent. The number of female drivers with 3 children in the car. So that's pretty straightforward, right? You do look at female, Yep. We look at how many females we've got, and they're looking at the number of female drivers with 3 children in the car. So we're looking at, I've got more females. So we've just got the number of children. We've got 1, and that's it. Okay, cool. So we've got a few more questions here. Let's have a look at this. So we've got the blood pressure. Low, normal, or high versus the age. We've got under 50, 50 years and over. Of 110 adults were recorded. The variables blood pressure. So blood pressure is what type of a variable is blood pressure? When it's low, normal, or high, that will be categorical, right? But I think they're asking for whether it's nominal, ordinal, nominal or ordinal. So what would you say blood pressure is, everybody? We've got some sense of order, right? So that's ordinal. What about under 50 years, 50 years and 50 years or over, what would that be? Guys, the more you engage, the more you'll get out of the session today. So we've got a bit of a discrepancy here between whether it's ordinal or nominal. So if you look at under 50 years or over, right? In that, although it's a categorical variable, right? When we say 50 years or over, the age, it's quantified. Does that make sense? So we know that people that are 50 years or over are actually older than the ones that are less than. So we've actually got two ordinal variables. Does that make sense, everybody? Yep, great. All right, so I think that's decent. That's a decent number of questions for that topic. We're gonna now move on. So I've got a fair few questions for you guys to trial out on your own time. I didn't exclude these only because I thought it'd be good for you to have all of the questions in the one area. If you have any doubts about the solutions for these questions, all you have to do is go and check it up on Weka. So hopefully by now you guys have had the opportunity to go and have a look at the Weka website. All right. For the second component, we're going to have a look at categorical data. So for categorical data, quite often what they would do is they'll provide you the frequency table. One of the main things that you really need to watch out for is when it comes to frequency, have they given the frequency to you in count or percentage? Okay. People make a lot of careless mistakes in this area. Now, a lot of the times they might tend to give you a count and ask you for the percentage, or they'll give you the percentage and they'll ask you for the count. Okay. So I've sort of put some notes there as to how you would go about calculating that. Then the next thing is you've got the segmented bar charts. For example, if I was asked to find, for the segmented bar chart as well, you could have either 100% adding to a total of 100%, or it could be a count as well, right? So depending on which of the y, which one they've used for the y variable, you'd have to pay close attention to that. And then to find out, if you were asked to find how much this value is going to be, you just have to go that value there, take away that value there, right? So if I say that was A and that was B, to find that will be A, take away the B, right? So these are real simple concepts. Also, quite often they'll ask you the question about the modal category. So that's the most recurring one. In this example, it's just going to be this one here. Alrighty. So let's move on to a few categorical variables related questions. So they're asking us over here. So look at this, right? Like I said earlier, they've got percentages as their frequency, and they're asking us to find out how many of the 96 birds have small beaks. Okay, so they've given it to us in percentage. We want to convert it into count. So count would essentially be, we've got, they're asking for small beaks. So we've got 25%, right? Essentially that's 25 over the 100 and multiplied by the 96. Okay, so that can cancel off. That's a 4, and we've got 24. Everybody okay with that? Yeah, pretty straightforward. Yep, fantastic. Using the percentage table, percentages in table 1, construct a percentage segmented bar chart. So over here, before I kick anything off, I'd look at what they've given us in terms of our y variable. And they're asking us to construct this. So we've got 25% for small. So I just go to the middle of that there and draw that line. So obviously when you guys are doing it, you'd use a ruler. And then I've got to go and add 25 plus the 44. Remember I said going up, the totals will add up. So the medium one's going to be, so that's going to be 69. So I'd have to go up to 69. So these are going in twos. You want to be really cautious about, it's awful. 69 is going to be up here. Fantastic. And obviously we've got to use the required shading as advised. Okay. Andrew, hopefully, are you there?
Yes, I'm here.
Hopefully we haven't got any latecomers that I've missed out on the file.
Yeah, no, I'm just optimizing the file and I'm going to distribute it again shortly.
Fantastic. Thanks heaps. Excellent. Guys, are you guys okay with the pace that I'm going at? It's only because we've got a jam-packed day. Let me know if you guys want me to slow down. Fantastic. All right, moving on. So like I said, I'm going to do three or so questions from each of the subtopics. And at the end of the day, if you've got more time, we'll come back to these later. Okay. All right. So let's have a look at this question. They're asking us to find name large UK cities with medium level of traffic congestion. So we want to go to large. So you go to large first, sort of highlight the large ones. And they want me to identify the countries with a medium level of traffic congestion. So that's congestions up here. When I look at medium, I've got medium over here. I've got medium here, and that's it, right? So I'll just say I've got Newcastle, Sunderland, right? I'm not going to write it here, but obviously you'd write the entire solution, and then we've got Liverpool as well, right? Fabulous. And now they're asking us to construct a what percentage of small cities have a high level of complete the following two. Okay, so first thing is we've got to complete the two-way frequency table. We've got 16 countries, 16 cities over here. We want to find out how many small cities have. So with this sort of thing, guys, I always find it easier just to take one thing at a time. So I'd go to small. So all the small ones first up. Highlight all of that. So I'm not looking at, I'm not making any careless mistakes, and hopefully I won't do that now. So I've got small with high, that's all sorted. I've got 1, 2, small with high, 3, 4, that's all sorted. And I've got small with medium. I need to go and check 1, 2, 3, 4, and that's it. So I've got another 4, which should technically leave me with 12. And let's see if that's the case. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Sorry, yeah, I should have 8 left, correct? Excellent. So we'll look at large. So can I get everyone to have a look at the ones with the large and give me the solution. So put high, comma, medium, comma, low, and send me the solution on the Zoom chat. So if I look at high, we've got go and highlight all the high stuff. Sorry, I've got to go and highlight all the large stuff. What am I saying? So large, 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 and large. That's it. And how many highs? Yep. So I've got 2 highs, and I've got I'm getting conflicting answers. So I've got 2 highs, 1, 2. I've got 2 mediums. That's right. And the rest are low. So I've got 1, 2, 3. Is that right? Yeah. Right, so that gives me a total of 7. Fantastic. They're asking us to find what percentage of small cities have a high level of traffic congestion. So small cities, I've got 16 of them, right? Pretty basic stuff. And how many of them have a high level of congestion? So that's 4 of them. And I'd multiply by 100%. So that's dividing by 4, that's 25%. Nice and easy, okay? So hopefully you guys are comfortable with that sort of stuff. Moving on to numerical data. So when we're talking about numerical data here, we're referring to univariate data, where we're dealing with just the one variable. The most common concept that they use is histograms and the you know, the different interpretations around that. So when it comes to describing a histogram, we know that we've got three shapes. So when you've got the tail towards the positive, towards the negative direction, you call it a negatively skewed histogram. With this sort of, you know, where it's balanced, we would call it an approximately symmetric histogram or a data distribution. And when you've got the tail towards the positive end, you'd call it positively skewed, right? When you're talking about the shape of a histogram, please make sure you are writing about the outliers. Now, for example, if you had an outlier like this, right? If you had something sticking out, we would write that the histogram is approximately symmetric. However, you've got an outlier at whatever the interval. So let's say if this was 220 to 230, I'm going to just use a variable, beats per minute, you'd want to quote that. Okay, so that's what you're going to get the full marks for. The next thing is the median interval. Now, to calculate the median interval, all we need to do is we need to find the position of the median. So to find the position, right? To find the position, you go and add 1 to the number of outcomes that we have, or the number of elements that they've given us, and you divide that by 2. So in this case, I've got 19 here. So 19 plus the 1 is going to be a 20. 20 divided by 2, that's going to be my 10th position. Okay. Now with the histogram, what we do is we keep adding these bars. We would keep adding these bars until it adds up to a 10. So let's have a look, right? So at this point, I've got 1. When I add 1 plus the 2, that's going to give me a total of 3. 3 plus the 3 is going to give me a total of 6. 6 plus the 2 is going to give me a total of 8. Uh-oh, do I have 19 data values here? What's this? 1, 8. I've made a mistake here, haven't I? I'm missing something. How many data values do I have here? Forget about this here, folks. So let's get rid of that. How many data values do I have? I've got 1, 3, 6, 8, 12, and 16. I've got 16 data values, sorry. So I'd go and say 16 plus the 1 divided by the 2, that's going to be 8.5, right? So 8.5, right? That's my position. So all I need to do is keep adding my scores until it reaches an 8. So over here, we've got 1, that's going to be a 3. Add that, that's going to be a 6. That's going to be the 8. So the median will fall where then? 17. Over here, right? Yep. So that's nice and easy for you to figure that out. Then in terms of the spread, we know that we would calculate the range. So the range is going to be maximum, take away the minimum. Okay. So let's have a look at a few, before we do that, we've got box plots as well. So essentially the same concept in terms of the tails. If you've got the tail towards the left end, you would call it a negatively skewed box plot. We've got approximately symmetric, and we've got positively skewed, as you can see here with these 3, right? Like I said earlier, you always want to mention whether there is an outlier or not. So if there is no outliers, you would say that there are no outliers. If there is an outlier, you would actually have to quote where that outlier is. Okay. Once again, you've got median. We always need to remember this equation here is only going to give us the position of the median. Okay, it's going to give us the position of the median, not the median. A lot of the times people make careless mistakes by leaving that as the answer. It is not. Then you've got spread. The spread of the distribution can be measured by we've got two different statistics. You've got IQR and range. So the IQR is generally preferred for questions that involve a skewed box plot or one that has outliers, because as we understand, the IQR is not affected by skewness or outliers. Then in terms of the range is preferred if our distribution is generally approximately skewed, approximately symmetric. Fantastic. So then the The
With that,
sorry.
I got a question with that.
Yep.
But if it is symmetric and you used interquartile range, would you be wrong? Even
No.
though it's not affected?
No. No, you could describe it. You could still use IQR to describe it. Generally, I mean, back in the day, before 2016, they used to ask questions around what's the most appropriate statistic to, determine spread. And a lot of the times when they ask you questions like that, it'll be a skewed one.
Yeah.
So yeah. Okay.
Very cool. So if you
great
use interquartile range, you're normally safe.
Yeah. Correct. Fantastic. So, guys, feel free to unmute yourself just like James did and ask questions, please. The more questions you guys ask, the more you will get from it. The next thing that we need to remember is when it comes to box plots, they quite often ask you to determine whether you have an outlier or prove that one of the data values is an outlier, right? As you know, for that we would have to calculate. We would have to calculate the lower fence and the upper fence, right? Generally, they will only need you to calculate just one of them. So they'll give you the lower end value and ask you to determine whether it's an outlier or not. So in that case, you would calculate the lower fence using this equation. Hopefully you guys have had a go at some of the practice exam questions before and you've seen this. We'll have a look at an example as well. Can I ask you a question now? Is the value for the lower fence an outlier or not? Is this here considered an outlier or not? No, it's not. Very good, right? So that's the smallest value that you can have that is not going to be an outlier, okay? And over here, this is the largest value that you can have that is not going to be the outlier, okay? So it's like your fence being a part of your property, all righty? That's that. Cool. I would like you guys to calculate the median for this question. So look at the number of data values that we've got. We've got 27. Then the next thing is, have we got this in order? Yes, it is in order. If it is in order and we've got the number of data values, you guys should be able to calculate the median really easy. All right, great. So we've got quite a few of you guys managing that, right? So B 3.1. So how you would go about this is you just go 27 plus the 1 divided by 2. So that's 28 divided by 2. That's going to be my 14th data value. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Then the next thing is you need to look at our key here, right? So to make sure that we're not looking at 30.1, they're saying 1/6 represents 1.6. Therefore, that would just be 3.1. Okay, nice and easy. Okay, so we've also got questions where we will be asked to calculate mean and standard deviation. Obviously, we wouldn't be doing any of this by ourselves or by hand. We'd be using the calculator for this. Now, I would like you guys to all attempt this as well. So for example, what are they asking us to do? They're asking us to calculate the mean and standard deviation for the variable distance. So what you would do is on your calculator, right? You'd go and open up listing spreadsheets, whether you use a TI Inspire or ClassPad. And you would normally when I'm labeling variables, I'd label it as DX, saying because it's a univariate data value, it's just only one of the variables. I'd add all my data values going down, right? Like that. Now, one of the key things to remember with this type of question is, guys, a lot of people make the careless mistakes in their data entries. Unfortunately, I mean, in this case, because we got set answers, we might get away with making a careless mistake because we'll go, hang on, I haven't got that solution. But it's really important that when you're entering your data values, because ultimately they have no way of verifying how you've done any of this. When you're entering your data values going down, you enter them. But before you go and do your one variable statistic calculation, please make sure you go up one by one and double check your values with what's on this exam. Does that make sense, right? So it's really important that you do that, because otherwise you're going to make a careless mistake somewhere and walk out of the exam thinking you've done well, but unfortunately you've just lost a few easy marks. Okay. All right. So I've got quite a few of you guys saying it is C. I'm going to trust you with that. Like I said, you'd only have to do one variable stats for this, right? Okay, pretty simple. Cool. Let's have a look at this question here. So this is to do with positioning once again. Now, to be able to do this, we would have to recognize Q1, median, and Q3, right? I'd like you guys to have a go at this question as well. So I've got 50 data values. The middle value is going to be between 25 and 26. So I'm just going to go and count 1, 2, 3, 4. Actually, if I look at this question, it looks like the medians are all the same. So I shouldn't worry about my median then, correct? Right? Yeah. So I'd just go and find Q1 instead, right? Actually, sorry, take that back. I've got to go and find where it is. 1, 2, 3. So that's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So it's going to be somewhere here, right? Then I've got 25 data values here, right? I need to find the middle of that 25. So I go 25 plus 1 divide by 2. So that's going to be my 13th data value. So I say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So unfortunately, once again, that's all 30s as well. Didn't quite need that either. Let's see. Okay, so we might be able to eliminate one of the variables, one of the solutions by looking at Q3. So I'm going to count back 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So is that going to give me the same thing? Yep. So that's also 50. So that's not going to be, can't be this one. Now I've got Q3. I need to calculate my upper fence, right? So I'm going to look at my upper fence. That's going to be Q3, take away Q1. That's my IQR. So I've got upper fence is going to be equal to Q3 plus 1.5 times the IQR. What's our Q3? We got, that's approximately a 50, wasn't it? Yep. Plus 1.5 times 50 take away, we've got a 30. So that's 50 plus 1.5 times the 20, that's going to be a 30. So anything above an 80 is an outlier. Can't be that, can't be that, can't be that. It has to be that one there. All right, yeah, everybody good? So we've got quite a few people saying B. Hopefully you guys understood what I did there. I could have probably easily eliminated some of the solutions by looking at, by identifying the fact that they all seem quite the same, but it's always good to double check, okay? Cool, all right, so how much time have I got? I got 9 minutes left to go before I start the next module. Let's move on to, where are we? So that's all univariate data, folks. I'd like you guys to attempt those on your own. Like I said, I'll give you guys the solutions. So I'm going to cover log-based before we go back to some of those questions. Okay, so if you can scroll down to the log-based 10 scale notes. Good. All right, let's get cracking. For log-based 10 scale notes, what I've got here is we use the log base 10 to try and restrict our domain. Okay, so when you've got really large X values, it's not practical to fit them in a histogram, right? So what we do is we put all our data values into this log base 10 scale, and that will really constrict that those larger values, right? So you will notice that when it comes to a histogram that's in log base 10, you would have, the X values would be 0, 1, 2, 3, and -1, -2, and so on. But they're in 10 to the power of. So a 1 here, the 1 here is actually in 10 to the power of 1, which means you're looking at a 10, right? So this interval here is actually going to include data values between 10 and 100. Alrighty, any questions? No? James, I think you're on unmute. Did you have a question there, mate? No? Cool.
No, I'm on mute. I think.
Oh, sorry. All right,
Yeah.
all good. Then we've got the conversions for these. To go from an actual data value to a log data value, all you need to do is, get the log base 10 on your calculator and enter that, right? So can I get you guys to just trial that on your calculator really quickly? Just put log base 10,500 and tell me what that gives you. I'll just do this myself as well. 1,500, control enter. Do you guys get a 3.18? Yeah, very good. Quite a few of you getting that. And then the next thing is if they give it to you in log base, to convert it into an actual, right? So over here, I've just done an example. If they had given you, the weight of something in terms of log, all you'd have to go and do is raise it to the power of, raise 10 to the power of that value, okay? So in this case, they've said log of a weight is 2.7. So you'd go 10 to the power of 2.7 and you'd find the actual weight. So we are gonna have a look at a few questions. Let's have a look at this question here. They're asking us, the histogram above, well, on the side, displays the distribution of, we've got 58, okay? Countries.
So Amy asked whether do you write the log manually?
Yep, so you could go, well, I use a TI Inspire. You would have to use, what calculator have you got there, Amy? Okay, fantastic. So you'd go control and 10 to the power of. Okay, so if you go control 10 to the power of, that should give you the log, and you should be able to enter 10 and then the number. Can you confirm that you're sorted for that? Amy? Yeah, all right. CRT, yeah, just press 10 to the power of. Okay, I'll show you this. So you go control, and then you've got 10 to the power of X. You'll see something called log there, just above that. All good? All right, brilliant. Okay, so moving on. We've got this question over here. We've got 58 data values. They're asking for the percentage of countries with an annual per capita greater than 10 tons. Now, when they say 10 tons, right? Remember, 10 would be represented by a value 1. Yeah, everybody okay with that? So we would look at greater than 1, right? How many do we have greater than 1, guys? We've got just one value. Is that right? Yeah, we've got one value greater than 1, and that is out of 58. So you go and say, well, 1 over 58 multiplied by 100%. Okay, so like I said earlier, there's quite a few questions where they will ask you to convert between count and percentage and count. Okay, so let's do this really quickly. I've got 1 over 58 multiplied by 100%. That should give me a 1.72, closest to a 2%. Alrighty, very good, Raj. Fantastic. Let's have a look at 2016 question number 7 over here. Is that a decent size on your screen? Can you guys see that? Yeah, awesome. So question number 7 here. Based on the histogram, the number of countries with 1 or more billionaires. Now, when they say 1 or more, right, we're going to go back to our log base 10 scale. 1 is represented by the 0 on that scale. Okay, so hopefully, will we get a copy of this, including the working out? Yes, correct. So you'll get a recording of this, Jessica. So I'm looking at this value here. Now I've got to add up the total. So I've got, what's that? That looks like 9 of them. and that looks like one of them. So I've got 9 plus the 1 gives me 10. Okay, everybody okay with that? Fantastic. I've got people responding. Great stuff. So let's move on to this one here. Let's do one more question before we take a quick break. So what have we got? We're looking at less than 10 people per square. All right. So when we say, when we're using the value 10, what are we looking at? We're looking at what number on the log scale? Guys, 1, very good. So we're looking at 1, and they're wanting values less than this. So I've got 5 here, and I've got 2 here. So I've got 7. And they're not asking for it in percentages. They're looking for how many, right? So I'm comfortable enough to say I've got 7 of them. All right. So guys, once again, we've got quite a few questions here for you guys to attempt. So hopefully you guys will have plenty of time to go have a look at these. Like I said, if you need to find out solutions, you'll find them in the Weka website. Okay, so I had a break plan for 10:45. So we're a few minutes behind because I had to do some introductions at the start. But let's take a 5-minute break and we'll come back to this. All right. I'm just going to go back to some... we're back, folks. Is everyone here? Can I have a thumbs up if you are? Excellent. All righty. Like I said earlier, all of this is being compartmentalized into the different style of questions. So if you've got any area that you're not, any area that you're not quite comfortable in, the best thing to do is try and revise that component. Make sure you're practicing all the questions relevant to that concept. And that means you're at 100% of being able to score those, content relevant to that concept, right? Or questions relevant to that concept. So it's the best way to strategically work towards exams rather than just doing a whole bunch of exams where you're consistently losing marks. So normal distribution, it is a concept that we know we're definitely going to get tested on. And over the years, they've got different variations that they've applied. Hopefully you guys have seen this before. So we know that 68% of the data values fall within 1 standard deviation from the mean. So that's our mean. And then we know 95% of the data values fall between two standard deviations from the mean. And we've got 99.7% of the data values falling within 3 standard deviations from the mean. Now, I know some schools teach this, but I've also gone and broken down these individual sections because over the years they've used, uneven standard deviation numbers and ask you to find percentages. So all you would do is, if they said, for example, let's do some examples later. Let's just cover the concepts first. So then the next thing is we've got calculating the standardized scores. We call them the Z score. You've got your actual value, take away your mean, divided by the standard deviation. And we've also seen questions where you compare the Z score, right? So if you've got a Z score of 2, that is, comparatively better than a Z score of 1, even if it's from a different assessment, right? Because you're comparing against the mean for each of these performances. And then, lately we've also seen questions where they ask you to transpose the equation to find unknowns. So they might give you, for example, they'll give you Z, they'll give you X bar, and they'll give you the standard deviation, and they'll ask you to find the X value here. So I've got a few notes. What you mean by Qs? What are you talking about Qs? Questions.
Yeah, so we have questions.
Yeah. Thanks, Myra. So I'm referring to I'm just saying use add the percentages for more than or less than questions, and I'll talk you through a few examples in a moment as well. So
I also have a private question, sorry.
Yeah, go for it.
So which email do we ask for the recording? Because some of our participants might be leaving early.
So which email? They would have to complete this survey at the end of it. And I believe that's when you receive the recording.
You do. Sorry, I might just jump in here.
Yeah.
Yeah, so as Adrian said, when you complete the survey, you should receive the link. If you have any trouble at all, then you're welcome to email myself or Annie, and I'll just pop our emails in the chat now. Thank you.
Also, Rachel and Adrian, it's Jane here. You can go to skylinefoundation.org.au and follow the links there on the landing page to register for the recording.
All right.
Thank you.
Thank you both. And thanks, Gia. Okay, so we've let's have a look at this question over here, guys. So they're saying the time spent by shoppers at a hardware store on Saturday is approximately normally distributed. So that's our trigger, right? When they say it's approximately normally distributed, we know it's a normal distribution question. And they're saying we've got a mean of 31 minutes. So the moment I'd see a question like this, where it says that it's normally distributed, all I'd do is I'd go draw a line, draw one in the middle, and I'd go 1, 2, 3 going to the right, 1, 2, 3 going to the left. And then I'd put my mean value in the middle. So they've got 31 minutes and a standard deviation of 6. So going to the right, I would add 6 each time. So that will give me a 37, 43, and a 49. And going to the left, I would subtract 6, and that gives me a 25, a 19, and a 13. And we are asked to find if we were to have 2,850 shoppers, how many of them will spend between 25 and 37? So between 25 and 37, we're talking about this bit here. And we know when we look at this question here, this note here, that we've got 68% of data values fall within one standard deviation. So you would go and say, well, that's 68. 68 would be if I had 100 of them. But in this case, I've got 2,850. So folks, what's my answer then? I've got 68, control divide, 100, multiplied by 2,850. Brilliant. So I've got D, right? It's closest to 1,900. Thank you guys for sending those responses. That's what I want to see. Fantastic. So we'll do one more question about Z scores here. Determine the standard score or Z score for the suburbs population density. So when they say population density, we're talking about this here. And they've said, we're supposed to calculate the Z score for that value there. So we've got Z is equal to X, take away the mean of X over the standard deviation. X I've been given is 3,082. Take away the mean of X, I know is 4,370 over 1,560. So what are we going to get for that one? We've got 3082 minus 4370 divide by 1560. Now, I've got a negative 0.82 whatever, but where people lose the easy marks is because they don't look at this question. So I've got a few of you guys have responded, sorry, it's meant to be 8.3 something, saying it's 8.3, but the actual solution should be what? 0.8, right? See, right? So you got to make sure, and I'll talk about a few tips at the end as well, or during our lunch break. You've got to make sure you're double checking the number of decimal places. For further maths, students are notorious for making that careless mistake. Okay, so if you want to get a really good score, one of the key things that you'd want to do is minimize making those careless mistakes. All good? All right. Cool. Interpret the Z score. So when they say interpret the Z score, we've got a negative 0.8. So that's going to fall somewhere here. When they're talking about, we're asked to, with reference to the mean, what would you say to that? What can I get you guys to send me a quick Zoom message about how you would interpret a data value that is at negative 0.8 Z score? Come on, folks. Yep, very good, right? So we've got 0.8 standard deviations less than the mean, yeah? Less than the mean. Quite often, they'll also ask you to describe this in terms of percentages. So for example, if you were to have a value that falls somewhere here, you might say it's in the bottom 50% of the data values. If it was somewhere here, you would say it's in the bottom 2.5% of data values and so on. So if you do these questions, you'll come across a few examples like that. Okay. Excellent. All right. I won't have time for every single question, but like I said, all the solutions are going to be on your Vika website. So just search up the exam and the question number. You'd find the solution to it there. Cool. So we're going to go through our second component now. This is where we're going to talk about bivariate data, right? So bivariate data is going to explain the relationship between two variables. Okay, so we've got to be conscious about the two variables, the different types of variables that we'll be dealing with. And in almost every exam, we have a question where they ask us to recognize what the response variable or the explanatory variable is. Okay, so in the past, they used X and Y and independent and dependent, but now we call it explanatory and response. I've got a little note here where we say, you know, the response really depends on the explanatory variable.
There you go.
Right?
Just checking in. Yeah, checking in.
Jane, I think you're not on mute, Jane. Yep, sorry. Cool. So if I ask you guys about this question here, I've got number of practice exams completed versus subject score. What would you say is the response variable? Response is going to be the subject score, because your subject score will be affected by how many practice exams you would have done. Okay, so we say it's directly proportional, right? So the more exams that you do, the better your subject score will be. Okay, so that's one way to recognize. Just think about, you know, what's gonna contribute towards what, right? And that'll help you determine that. We've got a few examples. So really easy. They're asking for what the response variable is. It's going to be your Y variable, so that's going to be population. Once again, asking for your response variable, that's going to be relative humidity. They're asking for the response variable, again, that's going to be evening congestion level. It's really straightforward, right? So I'm not going to spend too much time on this question, on that concept. I'm going to move on to the next stuff. The next thing is where you're asked to describe the association between categorical variables, okay? Now, I've got a little bit of a two-way table over here. What I want you guys to really focus on is when we are comparing data values, we always compare across one of the rows, okay? We always compare across one of the rows, not going down. And we always only compare percentage only. So if we don't have values in percentages, we will have to convert it into percentages to make meaningful sense out of it. Then, if the percentages are different, for example, in this, I think this is an example from our textbook, right? We're talking about attitude towards gun control. We can see that, you know, a higher percentage of females, 71%, are for gun control compared to males. So if the values are different like that, that means there is a relationship between the person's attitude towards gun control and their gender. Does that make sense, guys? Right? So we want to see different values to establish a relationship. Let's say we've got similar values. If we've got similar values, let's say, you know, I had a 55.3 for males and 56% for females, right? If we've got similar values, we say, well, there's no relationship, because it doesn't matter if you're a male or a female, your attitude towards whatever it is not going to change. Okay, so let's have a look at a few examples, and the same concept will apply for segmented bar charts. Now, as a statistician, if you're doing anything related to statistics, you can really play around with the numbers, right? If you want to establish a relationship, you would show different values. You'd compare different things across. If you want to say that there's no relationship, then you'd look at similar things across, right? So let's have a look at an example here. This question here is asking, you know, write down the percentage of people in Australia who were aged between 10 to 14 years. So 10 to 14 is our dark one here, the black one. And
Sorry, Adrian, we have a question.
Yes.
So how similar does values have to be to show no relationship?
I mean, with weaker exams, they're generally pretty good, right? They don't try to stump you with like, curveball questions like that. So I would say if it's within like 2 to 3%, that's similar. Okay. So if it's within 2 to 3%, that's similar enough. But with weaker, they're quite distinct. They'll be, really different, more than 5 would be the common sort of style of question. Hopefully that answered your question there. So we've got, let's have a look at this question. So we've got, we're looking at Australia. So what's this? About 19%, I'd say. Right? At least that's what it looks like. It's a little bit blurry on my end. And then they're saying in 2010, once again, it's one of those questions where we're asked to calculate the count, right? We've got 128 million people. They want us to find out the number of people that were aged 65 years and over. So I'd go to Japan. I'd look at 65 and over. So what's that roughly? What's this? We've got 100 minus, that looks like it is a 77. Is that right? Looks like it's a 77. On an actual exam, it'll look a lot clearer, guys. This is a bit pixelated here. So we would have, that's 23%. So that's 23 over the 100 multiplied by 128 million, right? So this was a part of my note at the start, where I asked you guys to, I said there'll be a lot of questions where you would compare against. Fabulous. And now we've got one of these questions where we are asked to establish whether there is an association or not. Now, it appears that there is no association between the percentage of people in the 15 to 64 age group. Okay, excellent. So we go to 15 to 64, right? We've got this thing here, right? And we're comparing them across. We would definitely need to mention the percentages, okay? So we have to always quote appropriate values. So to write the solution for this one, we would say, so what's this percentage? We'd have to calculate this. Can I get everyone to have a go at giving me the values for Australia first, India, and Japan? So that's 15 to 64-year-olds. So we've got 86% take away, that seems like a 19. And this over here is going to be a 95 take away, that looks like 31. And over here we've got 77 take away, looks like that is a 14. Okay, brilliant. So we've got 67%. Okay, 64 and 63, right? So great. So we would say, explain why quoting appropriate percentages. So you would say the percentage of 15 to 64 age group for Australia. Inside brackets, you said the answer was 67%. India. Inside brackets, you'd write the value, that's 64%. And Japan, inside brackets, you'd write the value, which was 63%, similar. Okay, so remember I said to show that there is no association, you'd have to show that they are similar to each other. Alrighty, cool. So I think that's a decent number of questions to do for that topic. They're quite simple. I would encourage you guys to go and attempt these questions and double check your solutions with the weaker website. Now we're going to look at comparing numerical and categorical variables. Would we have the list answer the one more question? I would strongly encourage you to list out all values there, Tara, because we don't want to give them any room to take any marks off. Okay. I know that a lot of the times if you just compare across and you've got two of the things that's decent, but I would always list out all three and show that they're all similar because we've got three variables. Cool. We're going to compare associations between numerical and categorical variables. Now, very common style questioning. We would have to compare box plots and stem plots. When we're comparing, we would compare shapes and outliers. We'd compare medians, and we'd compare IQRs and ranges. I've got a bit of a note here, talking about battery life. We say, if you've got the median battery life for A greater than median battery life for B, I can state that on average, brand A batteries have a longer battery life compared to brand B. Okay, so that's why we use the word on average there as a disclaimer. If I've got a scenario where in this question you can see the IQR of A is greater than the IQR of B, you would say on average brand A is more variable, right? Okay, so the values tend to range a bit more than brand B. I've got a few keynotes here as well. Always make sure you're quoting your values, okay? Always make sure you're using the proper decimal places as advised, and make sure you're writing the units as well, okay? So that's what you want to make sure you're doing to get the full marks. All right. Hopefully you guys are okay with the pace that we're going at. Please let me know if you want me to slow down. Just use the chat message. Fantastic. So, one other thing I want to cover is that when it comes to box plots, the percentiles are always consistent and can be identified. That when I say percentiles, I'm talking about the percentage of data values will always remain the same in between quartiles. Okay, that's an important comparison as well. If you got something.
A note from someone who asked, wouldn't the average describe mean, not median? So wouldn't saying on average be wrong? Wouldn't you say the middle value of the data is higher for A?
No. So this on average here, we're not talking about an average value. We're talking about in general. The word on average there is just saying in general, brand A lasts longer than brand B. We're not talking about the average there, yeah? So that's just a disclaimer that we use for any stats related question to say when we're not saying that this is the be all end all, okay? Hopefully that answered your question. Once again, over here as well, we've got 25%, 25%, 25%, and 25% again. Okay, so hopefully you guys are understanding what that means. So let's have a look at this quite common style of question. They're asking us to find out which one of these is not true. Okay, not true. So the parallel box plots, we've got outer suburbs and inner suburbs, nice and easy. We're talking about population density. Now we've got to go and see which of these statements are not going to be true. Okay, more than 50% of outer suburbs, right, have a population density below, population density below 2,000 people per square kilometer. So if I go to 2,000, that's here. Is that more than 50% of them below that? Yes, it is, right? So that's true. Then the next question, next option. More than 75% of inner suburbs have population densities below 6,000. So if I go to inner suburbs, then I go to 6,000. Is it more than 75% of them below that, guys? Yes, no, yes, right? So that is also true. Then the next thing, population densities are more variable in outer suburbs than inner suburbs. Is this true? Right? So I'm just going to put an asterisk mark here. I'm going to come back to it because they've said variable, right? The median population density for inner suburbs is approximately 4,400 per square kilometer. So for inner, is it 4,400 roughly? Yes. Then the next one, population densities are on average higher in the inner suburbs than outer suburbs. Is that correct, guys? Right? It's that statement that I made earlier. Isn't that right, guys? Yeah. Tara, do you understand what I meant by that? Sorry, whoever who asked the average question. Yeah. So that is also true. So then the only exclusion should be this one here. Everybody okay with that? Good. Brilliant. Let's have a look. So we've got 15 minutes to go. I reckon we'll go through the different topics and then we'll come back to any questions when we have some time, okay? Moving on to numerical variable nodes. As you guys know, this is one of the biggest areas when it comes to the data and statistics questions. To describe scatter plots, we use 3 different things, right? We would compare the strength. Strength is how closely packed the data values are to that linear regression line. So if it's extremely close, we say it's a strong relationship. If it's loosely packed, we would say it's moderate. And if it's like, all over the joint, we would call it a weak relationship, right? Direction is important as well. So if it appears that our y values are increasing as our x values are increasing, we say it is a positive relationship. If our y values are decreasing as our x values are increasing, we say it is a negative relationship, okay? And then we've also got form as well. So for form, we've got linear and nonlinear, and it's really easily distinguishable as well. So let's have a look at a few questions to do with the association between numerical variables. Cool. All right, guys, can I get you folks to use the chat function really quickly and message me what you would say for the strength and direction of this relationship? Come on, folks, don't be lazy. Yeah, strong positive association. Okay, brilliant. How about this question here? What would that be? Now, one of the things to note, I'm going to go over this later on as well. We've got the coefficient of determination, right, which is r squared. Now, what I can actually recognize is I can go and calculate the correlation coefficient by square rooting the 0.416, right? So if I square root that, what do I get for that? 0.416, control enter, that is a 0.6449. Now, and that should be a negative, right? Now, some of you guys have gone and said it's a weak negative linear, but I would actually go and do a bit of a side calculation. That doesn't look like a weak relationship, folks. Does that make sense, right? How do I know that? So we need to look at this thing here, right? So if it's a 0.64, right, we'd use this, right? Right? See, it is a moderate negative. Does everybody understand what I did there? Right? I calculated my R value to help me determine whether it is, weak, strong, or moderate. Okay. So in this case, I could say that that is a moderate negative relationship. Okay. Now I can't state anything about the form at this point because what if you don't have the R value? If you don't have the R value, that's a different story. Then you'd go with the visuals, right? And like I said, they don't leave any room for ambiguity, right? They want you to get the right answer. For further maths, there's only one solution a lot of the time. So it's up to you to make sure you've used all the variables and all the information that they provided to you. Okay. So make no mistake, if there's not going to be, multiple answers. Cool. Correlation coefficient. Once again, we're looking at our R value. In multiple choice questions, guys, I've seen this quite often. People make the careless mistake. They give you something like this, right? They'll give you a graph that looks like that. They'll give you your R squared value. They've got a whole bunch of multiple choice answers. People forget that the direction is negative, okay? So please don't make that mistake in your exams when you're doing this style of question, Okay, so
Hello, Adrian. Sorry, I'm not sure if you answered this already, but what if you don't have the R value?
I just briefly discussed that already, Jimin. Thank you. All right, so let's have a look at this question, guys. This is one of those questions where you'd have to use the calculator, plug in the data values, and find out where the correlation coefficient is going to be. So I would really appreciate it if you guys can go and do this question. So let's have a look, right? What we're trying to do is we're trying to calculate the R value. So first thing is we are asked to calculate the R value between LBM and percentage body fat. So that's LX, and percentage body fat, I would label it as PY. Okay, I always label it like that because it helps me and I don't have to rethink about the question when I'm trying to do the calculations, right? So please plug in these data values on your calculator. All right, so I'll give you like a minute to do that. Like I said earlier, the biggest mistake that people make is they don't double check their data values. Okay, so you enter the data values going down, you double check your data values going up before you go and do any calculations. For this, you'd have to perform linear regression, right? Not two variable statistics. So you'd have to perform linear regression. I hope you guys are comfortable doing that on the calculator. Does anyone have any questions about the steps, or is everyone okay with that? I'll take that as a yes. All right. Can I have you guys do this on your calculator and let me know what the solution is, please? All right, where are we up to? Correlation coefficient. All right, brilliant. All right, I've got a negative 0.124. Can I have a second person just confirm that for me? Thanks, Kaya. Excellent. All right, so we've got that sorted, right? There's quite a few examples here if you want to go and try this out on your own. It's a good way to try and make sure you're understanding a certain concept really well. Okay, so I've got until 11:30. I've got 9 minutes. Cool. Then the last thing that we need to remember for bivariate data is correlation and causation. Okay, so I've got a few notes here. Now, correlation tells us about the association between the two variables. It doesn't tell us anything about the cause of the relationship, okay, or the cause of the association. Let's talk about this example here. I'm obviously not an artist, but hopefully you'll understand the gist when I explain it to you. So let's say I've got an ice cream parlor near the beach, okay, and I'm selling ice creams. And I noticed that the more ice creams I sell, the more people tend to drown, okay, in the ocean, okay? So does that mean that, eating ice creams, means that you can't swim properly, okay? Is that the association that we're seeing? It's not, okay, right? It's not. So what this sort of a variable is, what's happening here is we know that when the sun is out and the temperature is nice and warm, that is when people will start eating more ice creams, right? They'll go and start buying more ice creams. But when the sun is out is when more people would also go swimming in the ocean, okay? So what we're experiencing here, or what we're witnessing here, is actually a common response to good temperature, right? Okay, so hopefully that makes sense to you guys. Then we've got another example here where we're looking at the economy, unemployment, and crime, okay? What do we know? We know that when the economy is bad, unemployment is going to be high. We also know that when the economy is bad, crime rates are going to be high. So it is a bit different common response because it's interconnected, okay? Everything's going to be affected. Unlike in my previous example, right? Selling more ice cream doesn't mean my temperature is going to go up. Does that make sense? Right? So when we've got a scenario where the variables are interconnected, we call it, we've got confounding variables, okay? And that's this example over here. Then we're going to look at another example where, I am a supermarket chain, and I noticed that the more butter I'm selling, the number of divorces in Australia seems to be going up. Okay, so does that mean that eating more butter is causing relationship breakdowns? No, it's not. Okay, we call this a total coincidence. Okay, so being able to reason and identify these different scenarios is also going to be important in further. Okay, is everybody okay with that? So we've got these three things: common response, confounding variables, and coincidence. All right, brilliant. So let's have a look at this example here. A lot of the times, guys, what they're trying to get you to do is try and recognize whether the relationship explains an actual causation or not. So let's have a read of this question. I would like you guys to have a read and have a crack at it. Flick me a message and let me know what you think the solution is for this one. So what I would first do is I would construct a rough diagram to help me recognize what the shape of this is going to be. Okay. We've got, what are they saying? We've got a negative association between time spent playing sports each week and the time spent playing computer games. So the more sports you play, the less computer games you would play. All right. Yeah, the more sports you play, the less computer games that you would play. Now, from this information, it can be concluded that male students who spend a lot of time playing computer games do not play sport. That is very aggressive language, right? So we can't make a statement that confident, okay? Because there might be some people that spend a lot of time playing computer games that also play sport, okay? So that's not it. Encouraging male students to spend less time playing sport will increase the time they spend playing computer games. We can't talk anything about encouragement here because we can't state that from the stats that we have here. Okay, so that's all just bogus language. We're going to exclude that one. Encouraging male students to spend more time playing sport will reduce the time they spend. Once again, we can't talk about encouraging. We're not here to mediate with anyone's behavioral stuff. All we're doing is we're looking at the stats and providing a statement based on that. Male students who tend to spend more time playing sport tend to spend less time playing computer games, right? That's correct. Right, but we're going to go and check the double check the next value as well. Male students who tend to spend more time playing sport tend to spend more time. That's not the case, right? We know it's not directly proportional. It's actually the opposite. Okay. Now, what I want you to recognize is this word here, tend to, right? Tend to, because we're suggestive, right? All that we can say is, well, it looks like they're more likely to. Okay, we can't make an exact statement where we say male students who spend more time playing sport spend less time playing games. We can't do that. Okay, right? So a lot of the times the solutions will have that word tend to or likely to. So those are some of the giveaways as well. All right, I've got 3 minutes to go. We're going to look at which display that we could use. So like I said at the start, we have been looking at bivariate data. So we're discussing the relationship between two variables. And over here, we've got a table. Mind my handwriting. We've got a table where we're looking at different types of explanatory variables or X variables and different types of Y variables. And that will help us decide which graph we would use. Okay, so a lot of the times we get a question like this in our MCQ section. So I just thought it's worth putting this in there. One thing to note is if you're going to use back-to-back stem plots or parallel dot plots and box plots. This is if you only have 2 categorical variables, okay? That's if you have 2 categorical variables. Other than that, it's pretty straightforward. First, you look at the data, recognize what type of variable it is. Then you look at the table and go, okay, that's the type of graph I would use. Cool. All right. So we are going to have a look at this question here. I'd like you guys to try and identify the variables. So first, recognize the variables and tell me, sorry, they're talking about a single back-to-back stem plot. So tell me what type of, I just described the back-to-back stem plot, so that's perfect. What type of variable would our categorical variable be? Okay, so the numerical variable has already been given to us, right? How many options can a back-to-back stem plot have, guys? I can only have how many categories? Oh, sorry, how many variables? I can have 2, right? And the only one here that has 2 is going to be the driver's sex, right? We've got male, so we could have female and male for the back-to-back stem plot. Excellent. Let's have a look at another question. So let's have a look at 2016, please. So this is a monthly median rainfall. So that's a numerical variable. And we're talking about parallel box plots. So the other one will have to be categorical variables, right? So we got categorical, right? And when they say parallel box plots, you could have multiple, right? We could have multiple categories. So obviously it's not going to be annual rainfall, which is a numerical variable. Can't be monthly sunshine time in hours. Once again, that's numerical. Ooh, we've got 3 categories here. So could be that. Can't be monthly median temperature because it's numerical. Can't be monthly median and wind speed because they're not related to each other. So median wind speed and kilometers. Oh, sorry, that's just one variable, isn't it? Yeah, so that's also, once again, numerical. So it will end up being C. Okay, cool. Fantastic. All right, so let's do a bit of a hokey pokey. Let's take 5 minutes and I'll see you guys back here at 11:35. Okay, we are back again. So we are now gonna move on to the least squares regression line notes. I'll give everyone like a minute or so to get back. Fabulous. So now the least squares regression line happens to be one of the most commonly tested questions. This, along with transformations, they tend to combine both of these topics. So I've got a few notes here really quickly before we jump into the questions. The format is going to be y is equal to a plus bx. We know that the slope is represented by this value b. I've got this over here. So if they give you the stats, if they give you r, standard deviation of y, standard deviation of x, the mean of y, and the mean of x, then you would use these equations to calculate it. But if they've given you the data values, you would obviously use the calculator and perform a regression analysis to calculate that equation, okay? Can I confirm that you guys sort of understand what I'm trying to say here? So this is when they give you the statistics. Perfect. It's really important that you define the explanatory variable and response variable correctly from the onset itself. Cannot highlight this enough. Calculator entries, this is the area where people lose easy marks. Okay, you go into that exam, you're super confident. Please don't, make those careless mistakes. Even if you're cut out for time, you don't get marks for finishing it fast. You get marks for finishing it correctly. So I would definitely encourage you to go and double check your values before you get started. Then we also substitute X values to go and predict Y values. And you've got, when you're predicting, if you're predicting using values outside the given range of X values. So for example, you've done your regression analysis, it looks like this, and you're using anything outside this X and the smallest X and the smallest Y value, we call it extrapolation. And those sort of predictions are less reliable. Less reliable. Anything within this range of given data values, we know it's interpolation, and we would say it is more reliable. Now, guys,
I have a question.
Yeah.
From the audience. So if values are incorrect, could we gain half marks if the other values are correct?
So do you mean, we'll come to that question when we're looking at actual examples. It's unlikely that you would get one value wrong and the other is correct. Does that make sense? Because it's all done on the calculator. And unfortunately, there's no way of determining how you got those values. For all the examiner's care, you could just, think of random numbers and plug it in. So it doesn't work that way. So you want to make sure you've got everything spot on before you go and do any calculations. Guys, I would really like us to do a quick exercise. So if I could get you guys to jump on menti.com, and I believe this is on play at the moment. Let's see. And use this code here. Just go on menti.com and do a quick survey for me. So how confident were you feeling at the start of the session today about further maths? I'll do this again at the end as well. 10 being I'm extremely confident, and 0 being I'm not confident at all. If I could get you guys to just jump on that. Wow, nice. I've got a 10, got a few people. So just use that code up the top. So I'm just asking you how confident you felt at the start of the session before we kick things off. Cool, so around about a 7 or so. I'll give it a minute. So everyone's had the code is at the top there, Lily. It's 3320929. Can you see that? So let's say extremely confident being, we're looking at like a 45 plus subject score. All right, that's good. We've got 39 people that have responded. We've got about 77 here, so I'll give everyone a crack. 40. All right, looks like that's, I'll keep it on. So if you've got that code, you can just use that code and submit how confident you guys are feeling. Well, let's jump into the content. I'm super eager to try and finish as much as we can today. So let's have a look at this question, guys. What are they asking us to do? They're asking us to draw the least squares regression line, okay? To draw the least squares regression line, we basically need 2 coordinates, all right? So the first thing would be for you to go and determine these 2 coordinates. So I'd go and sub in 0 into the equation. So I know population is going to be equal to 5,330 plus 2680, right? When the area is equal to 0, we know I'm only going to end up with my y variable. So that's 5,330. So I'd go to 5,330. That is going to be approximately somewhere here, right? I'd draw a nice dot. I'd in fact go and say that's 0, 5, 3, 30. Okay. And then I would go and look at another variable. So I might use something nice and round, like 5 maybe, right? So I'll go and sub in 5. So that's going to be when I sub in 5 into the equation. Can someone tell me what that value is going to be? Actually, I'll just do that. 5,330 plus 2,680 multiplied by the 5. That's going to give me 18,730. So I'd go on to 18,730. So that's 18,000. That's 19,000. Can you guys see that? So 18,730 is going to be somewhere around there, I would say. Oops. Somewhere there. And then I just need to use a ruler and make sure I draw that line. Okay. And that needs to go all the way through. Okay. Is everyone comfortable doing that? So finding the 2 coordinates and then sketching the line through that. That's been a common style of question lately. Let's have a look at another question. So in this question, they've given us 2 coordinates, right? So they've given us our x and y variables, and they're asking us to calculate the slope of the least squares regression line. So hopefully you guys remember the gradient is given by y2 minus y1 over x2 minus x1. Can I get you folks to just have a crack at that and send me the response on Zoom? I'm just going to have a look at how much content I've got for this subtopic.
Are we allowed to use a ruler in the exam?
Yeah, definitely. So for least squares regression line, I've got, okay, decent chunk. All right, if you've got that sorted. So in this case, our coordinates would have been 1,700, 6.7, is that right? And 900, 10.7. Okay, and yep, everyone's saying the answer is B. So this is our first coordinate, this is our second coordinate. That means this will be y2 and that will be x2. This would be x1 and that will be y1. All right, everybody okay with that? Cool. All right, we've got a determining the least squares regression line question here. So I would really like you guys to use a calculator, plug this in. So if you look at this, guys, I've got something that starts with A and A, right? So I'd call this PX because they're saying, sorry, if you look at this, so they're trying to trick you because they've got actual temperature as your x-axis. So I'd say AX, and I'll call this PY, so apparent. So I'd go with PY, and that's an easy way for me to determine. So first thing that I would do is I recognize that they're trying to trick me, and I put AX on my left, or PY. I mean, you could, as long as you could recognize that this is your Y variable and this is your X variable, you're good. Okay. So can I have everybody chuck in the chat? Just chuck what A and B is going to be, please. So in this case, you plug everything on your list and spreadsheet, right? Everything on your spreadsheet first. And then you'd have to go and perform a linear regression. Make sure you are double checking your values when you're coming back up before you go and do your calculations. Yeah. So we'll go about 13 to 12, 15. All right, has anyone done this yet? Getting there? Cool. So Emily sent through a response. Brilliant. So it looks like everyone's getting that. Guys, what do we need to remember? We need to remember that they're asking us to give it in 2 sig figs, right? Okay. So 2 sig figs, that is going to be a negative 1.7 then, and a 0.94. Do you understand? Now, how do I identify significant figures? I would actually recommend you to write this down. I don't think I've given this as a note, right? So significant figures, really quickly. Significant figures, I'm gonna try and remember. So all non-zeros are significant. Okay, so if I say 1, 2, 3, 5, that's 4 sig fig. Then all zeros wedged between non-zeros are significant. So if I said 1005, that's 1, 2, 3, 4 again. Okay, then we've got all zeros, let me think, all zeros before the implied decimal place are not significant, right? I'm going to say insignificant, but not, I'm just going to say not significant to have that clarity. So if I say 1000, right, I've only, the implied decimal place is here, right? The implied decimal place is here. So I've only got one significant figure here. Do you understand what I mean by that? Yep. Hello. Yes, good. All right. Then all zeros after the decimal place, right, are significant. So if I say 1.00, think about it like this. Why would anyone say 1.00? There's probably some importance to those 2 zeros. Therefore, it is significant. Does that make sense? So I would say this here is going to be 3 sig fig. Okay. Then I would say all zeros before the first non-zero digit is not significant as well. Okay, so this is where hopefully you guys are writing this down. So if I say 0.0004, none of these are significant, only this guy is. So I'd say 1 sig fig. Okay, so hopefully that note will help you guys out. And if you want to take a quick screenshot, because I was flying through that, I've got that for you there as well. Are we good? Can I move on? Take a photo, thanks. Awesome. All right, so I also wanted to go over one question like this, where they give you the diagram and they want you to determine what the equation of the least squares regression line is. Now, the first thing to notice is people straight away jump into the conclusion that this guy here is our y-intercept. Unfortunately, it is not our y-intercept, because for us to have the y-intercept, our x value needs to be how much? A 0, right? So straight away, I can eliminate anything that says 7.4 as my y-intercept. Does that make sense, everybody? So I'd go and eliminate those 2 guys, all right? Now we're tossing up between, then the next thing I can eliminate is I can look at my x variable. For my x variable, I'm supposed to have length. So anything that has width as my x variable, I can eliminate again. Then the next thing is, okay, well, the easiest thing for me to do would be to go and determine what the gradient is going to be. To determine the gradient, I'll go and look at 2 coordinates. right? So I've got 7, 7.4, and I look for a nice coordinate where the line is passing through. So I've got 10, what would that be? A 10, 9, and I go and calculate the gradient. Okay, so can someone tell me what the gradient for this is? So you go 9, take away 7.4. I might do this myself. And then that needs to be divided by 10 take away 7, which is a 3. Control enter. I get a 0.5 something. So that's going to be this guy here. Everybody okay with that? Fabulous. All right, so let's keep moving. I think you've got a fair few examples like that that you guys can go and trial out. And you know, the solutions, once again, you'll find out. You'll find them on your on Vika as well. So I'm going to keep moving, and we'll come back to any questions that we have remaining at the end, because I've got until 12:15 before we have to start time series. Cool. So now we're going to look at using and analyzing the least squares regression line. Guys, they will always ask you to interpret either the slope or the y-intercept. So I've got a bit of a note here. Hopefully you guys have got something like this already. All you need to do is replace any of these things that are in black with the actual data that has been given to you, right? A lot of the times on the Vika examination reports, you'll find that they say, you know, people have used alien terms, right? Because, you know, the example on the exam is about birth rate and life expectancy, but people have written something about cars. That's because they're trying to copy it off their notebook, right? And accidentally in the time, you know, during pressure, with the pressure of the exam, they end up copying the wrong variable. So I would encourage you to have something like this instead. Now, although I've given this to you as a guideline, you can also sort of reword this to make a logical sentence. Okay, so for example, if I was talking about the value of cars and how long a car has been used for, we wouldn't say on average the value of a car is expected to increase or decrease by for every 1 year increase in age, right? Instead, we would say it will increase or decrease by a certain value each year it's been used for. Does that make sense, guys? Right? So we want to try and write something meaningful. Okay. Then the next thing is the y-intercept. So we would say on average, our response variable is expected to be A, which is our y-intercept. And you'd also quote the units when the explanatory variable is a 0. And similar to the previous example, or similar to the slope, we would try to write a meaningful sentence for this one as well. Okay. So moving on, let's have a look at this question here. Guys, please ask me questions if you guys have any. Whack them on the chat. If you want to send me a message privately, I'm more than happy for you to do that as well, or you could just ask Jimin as well. So she's been helping me throughout the session. So feel free to ask your questions. Okay. All right. So we're gonna interpret this one. So let's have a look. They're asking us to interpret the slope, and that is 2,680. This is an increasing question, right? So the gradient is increasing, or it's a positive gradient. So let's have a look. We would say on average. Okay. Let's say on average. I better try and zoom in a little bit. I would say on average, the population is expected to, what should I say, increase or decrease? Is expected to increase by, so look at this, see, this is what I'm doing, right? B is my y variable, 2,680. I got to talk about the unit, right? So what's the unit? These are people, right? Yeah. People. For every 1 unit. So I would say 1 kilometer square increase, isn't it? In area. Are we okay with that? Yep. Fabulous. Let's do the interpret the intercept. So let's do the y-intercept as well. So what is this one stating? So we've got to talk about the y-intercept. We've got that definition here. So you would say on average, the apparent temperature, isn't it? Our y variable is apparent. Sorry about that. Apparent temperature is expected to be, what's that? Negative 1.7. So I've got my A value, but I've also got to write my unit, right? Degrees Celsius when the actual temperature, right? When the actual temperature, which is my X value, right? Or my explanatory variable, is 0. Did someone have a question there? Or I would say 0 degrees Celsius, because that's what makes sense for this example. Oops, what am I doing? Are we comfortable with that, everybody? Yeah, excellent. Okay, so we might just have a look at this question here as well. Given the information about which of the following statements is not true. So you've got quite a few things happening in this question. They've given us the coefficient of determination. They've given us the equation. I'm just going to write that HDI thing here. So we're talking about the Human Development Index and the life expectancy. Okay, so given the information about which one of the following statements is not true, the value of the correlation coefficient is close to 0.94. So this is coefficient of determination here. We need to calculate the correlation coefficient. So let's see if that's true. So we go square root of 0.94, and that is going to be 0.8. Apologies, 0.875. That's going to be close to, that's correct. 12.5% of the variation in life expectancy is not explained by the variation in Human Development Index. Very good, right? So that's R squared. I believe I've got a note for that a little later on as well. So if 0.875 is explained, that's just saying 87.5% is explained. Then how much is not explained? That's going to be 100% take away that 87.5. So that is also true. Is that right? Yeah. Then on average, life expectancy increases by 43 years for each 10-point increase in Human Development Index. Is it 10 points? Is HDI in 10 points? It's not, right? So what should let's see. I'm going to go with this one. Let's see. Ignoring any outliers, the association between linear expectancy and so is a strong positive linear. That's correct. Using the least squares regression line to predict life expectancy in a country of 75 is an interpolation. Okay, so if the HDI is a 75, is it an interpolation? Yes, it is, because 75 is within our given range of data, so that's correct. So our incorrect answer is going to be this, right? Because they've said nothing about the 10-point increase in HDI. All good? Everyone okay? Good. All right, fabulous. So let's keep going. So let me see how many subtopics are we up to? All right, let's keep going. We'll go on to the next subtopic and come back if you've got any time, okay? So coefficient of determination, R squared, that tells us about predictability. So I've just given you guys an example note here. If you end up with 0.065, when you multiply that by 100%, you end up with, 6.5%, right? So that's what I'm trying to show you here. If you had 0.0a, when you multiply the percentage, the decimal place will jump twice, so it's going to be a%. And this is going to be our interpretation of the R squared value. So you would say, on average, what are the percentage of the variation in your response variable can be explained by the variation in your explanatory variable. And like I highlighted in that previous question up here, right? If a certain percentage can be explained by this statistic here, right? By this percentage here, the percentage that cannot be explained, will be given by 100%, take away that a%, okay? Are we good with that, guys? Yep, good. All right, so let's have a look at this question here. So they're asking us to identify what percentage of the variation in this population of suburbs is explained by the variation in area. So really straightforward. Have we been given the R value? Yes, they haven't given us the R squared value. So we would first find R squared, right? So that's going to be squaring that R value there. So you go 0.668 and we square that value. And I end up with 0.44. They want it for one decimal place. So like I said earlier, always be cautious about the number of decimal places. 446, when I multiply by 100%, that's going to end up giving me 44.6%. Okay, nice and simple. Let's have a look at this question. And I would like you guys to send me the response to that one. Determination. Okay. So it's a what do we have to do for this one? So first thing is, okay, Raj, what you need to notice is that they're saying it is a negative association. Remember I mentioned at the start when I was going through the R values, I said one of the common things is they'll give you that it is a negative association, right? But people forget to put the negative, right? So you would go and to find this, you'd always say, well, it's going to be the negative of the 0.141. Raj, are we good with that, mate? Yep, brilliant. Okay, so they want it for 3 decimal places, so we've got that all sorted. Fantastic. All right. All of those questions are quite the same, so I'm going to move on to the next subtopic. Guys, I'd strongly encourage you guys to go and have a crack at all these questions because it's topic based, and you've got a way to double check your solutions. If you've got a certain topic covered, you can be confident that you're going to nail that on the exam, right? So you've got residual analysis. So this is where you go and construct the residual plot. Very, very common error where people forget how to calculate the residual. Always remember, when we're comparing residual values, we're talking about an actual Y value, take away the predicted Y value. The predicted Y value will come from the equation. The actual Y value will either be given to you in worded form or it will be in the table of values. All good? Then the next thing is trying to establish an association. If you're, trying to identify whether an association is linear or not, you can look at your residual plot. If the residual plot indicates that there is no clear pattern, then you would say, it supports the contention that the relationship is linear. However, if you see a curved pattern of some sort, like what we've got here on the right-hand side, we would say, that the residual plot indicates that there is a curved pattern or some sort of pattern, therefore the relationship is nonlinear. Another thing to remember is that when we are calculating residuals here, we are looking at the vertical distance between our data value and our predicted data value. Okay, so we're looking at the vertical distance. So I've seen some MCQ questions like that in the past as well. So I reckon we'll jump into this question here. So in this question in 2016, they've given us the equation, perfect, right? They've said that, look at this, right? Winston is an inner suburb. It has an area of 4 kilometers squared. So they've given us our X value, and they've given us the actual population as well. So this is going to be our actual, this is going to be our actual Y value. Okay, so that's our actual Y value. Now, what we've got left to do is actually to go and predict the Y value first, right? So we go and say predicted population, right? Or predicted Y is going to be 5,330 plus 2,680 multiplied by the area which they gave us was 4. So you got 5,330 plus 2,680 multiplied by 4, control enter. That gives me 16,050, right? Now that's my predicted Y value. So to find the residual, I would say residual is, residual is gonna be predicted Y, right? Or predicted population minus actual population. Okay, so a lot of people struggle, some people struggle trying to determine what's what. Always remember you would put your predicted population, which comes from your equation, and your actual will generally be given to you. So in this case, they've said that's going to be 6,690, and that's going to be minus 6,690, which gives me 9,360. I'll be okay. Ooh, I think I made a mistake. Sorry. Did I write the equation wrong? Where's actual Y, right? Whoops. I've got the equation right, but I've written my stats wrong here. I should say actual population. Apologies, guys. Actual population, takeaway predicted. So actual was 6,690. Takeaway predicted was 16,050. So that would be negative 9,316. Yeah. Thank you, Jeremy. All good. Are we okay with that? Hopefully I didn't confuse you guys. Yep. Great. And what's my next? All right, let's see how much time we've got. We've got about 5 to go. Residual analysis is done. And then we've got transformations. Okay, so transformations, I've got a few notes here. So we use the circle of transformations to determine what type of transformation we'll be using. More often than not, they will tell us which transformation to use, and they'll tell you which variable to apply the transformation for. So it's really straightforward. It's not like the SACs where you had to determine that. I've got the calculator functions here for just one of the transformations each. I've got the TI Inspire steps as well as the ClassPad steps for you in case you get stumped on anything. Some of the notes here that I've got is that please make sure you apply the transformation only to one of the variables at a time. We wouldn't do it to both of them. And also the next thing that you need to be cautious about, I've seen this in a lot of the reports, is that students incorrectly predict when the transformations have been applied to your Y transformation. Okay, so for example, sorry, Y axis. For example, if you've got a Y squared transformation and you're asked to predict the Y, once you have substituted the value, you would have to square root it. Okay, is everyone following what I'm saying here? Yeah, right. Like if you've got a log Y, to find out what Y is, once you've substituted and predicted it, you'd have to raise the 10 to the power of the solution. Okay. Do you have to write that in the exam? No, you can do it on the calculator. You can say menu algebra solve as well, Amy. But this is for you to understand that, if you've got a transformation done on the Y, there's going to be an extra step involved in trying to find out what the Y value is going to be. All right. So I think what time? 12:15. I was supposed to start time series. That's okay. So we'll have a look at this question here, guys. We'll just do one example. So what I would like you guys to do is really quickly go and so we've got population. So I would call this PX first, right? And I've got area. So I'd call this area of Y as advised. And then they want us to apply the log to our X variable. So you would say AY, this is PX, and then you'd say LG, so log, hang on, whoopsies, apologies. What are we talking about? We're talking about AX, isn't it? And PY. My bad. So we are in this case we've got AX and population, which is my Y variable, and I want to apply the log transformation to A. So I'm gonna do LX, right? So that's my X variable. Now on the TI Inspire, so you would enter all the data values going down like that. On the TI Inspire, all you have to do is you go = log base 10 and select the variable by clicking VAR, right? You select the variable and you would select AX here. That's for the TI Inspire. Are there any students here that's using the ClassPad that's not across this step of using transformations? Anyone want me to go over that, or are we okay? Okay, so looks like everyone's all good. So plug in the data value. Oh, go over it. Okay, so what we would have to look at is, so with the ClassPad, you would label it as, you know, AX and PY. However, for you guys, what you've got is the equation, I believe, goes in the sort of lowermost row. Okay, so I'm conscious that people might be looking at this, but really quickly, I'll show you what I mean by that. So we're looking at the ClassPad and we're trying to do the log transformation over here. Can you see that there? Is it iron? Yeah. That's where you would enter it. Okay, so you would go, you know, you go and type in the calculation cell, you go and say log of whatever the variable. So not GDP. In this case, it'll be AX. All right, guys, plug that into your calculator. Like I said earlier, double check your values before you go and do anything. And then you would go and perform a linear regression where your X variable will be LX, because that's what we labeled it as, and your Y variable will be PY. So can I have someone give me the A and B values for this, please? Anyone sorted? just double checking that someone's actually doing this, because otherwise I'm going to go in and plug it in my own calculator. Can someone let me know if you've started entering the data values? Cool, that's fine. I might do this on my own then. So what we'll do is we'll take a short break and come back to this question again. So I'll give you guys a 5-minute break again before we come and start off with time series. So let's take a short break. And I'll go over. So I'll leave this for you guys on things to have a look at during the break. Let's take 5 minutes and I'll try that question for you guys and go over the solution. Amalia, you're not on mute.
We have a question. Are we entering all the values on the table?
Yes, we are. Ooh, are you guys still looking at this one? Yes, we need to enter all these data values. So I'm going to do it myself. So I'll call it AX 1.6, 4.4, 4.6, 4.6, 7, 7.3, 8, 8.8, 11.1, 13, 18.5, 3. Double checking our values. Has anyone done this yet? 66.5, 62, 27, 24.2, 20.
Yes, someone has done it.
Yep.
Jeremy,
you're in. Yeah, we are entering all the data values, Jeremy, but we have to also go and do the calculation afterwards. So I'm just getting through I'm just double checking my values really quickly. 62.1, 27, 24.2. 1.6. I've got population Y, 5.2, 14.3, 7.5, 11.0, 17.1, 19.4, 15.5, 11.3, 17.1, okay, 18.9, and I've got 31.3, and I'm gonna go and calculate my. All right, so let's have a look. I've got an answer from Emily. Let's double check. Danny, but not sure if that's correct. That's fine, Tara. Do you want to privately message me then? So I'll say LX equals sign. I would go and say log base 10. and select the variable AX, enter, on a normal calculator. Menu 614, X list is LX, PY. All right, brilliant. So Emily, you've got that one right. So you end up with a 7 point, what do they want? Two significant figures. So you end up with a 7.7 for the first one and another 7.7 for B. Okay, so guys, if you are not comfortable with this, I would strongly suggest you to have a look at these examples here that they've done. I've sort of cropped it up for you. And have a crack at that because this is going to be an important part, and quite a lump sum of marks that are allocated towards transformations in both MCQ as well as the extended response, as you can see. Cool, guys. Let's take 10 minutes. So let's take 5 minutes because I'm going to give you guys the lunch break at 12:45, I believe. Let me see, what time do we have lunch set up for? What time do we have lunch at? Sorry, 1 o'clock. So I'm going to give you guys lunch at 1. So let's take 10 minutes, guys. Go for a bit of a stretch, grab some water, and I'll see you guys back here for the time series components. When we return.
Adrian.
Yes.
How you going?
Good.
Yeah.
How are you?
Doing a great job. Just wondering about the UBS videos. Have I missed
I'm gonna set it up now because I'll have to share it using my computer. So I've got Jimin's recording that I'm gonna play when we return from the break.
Great. It'd be lovely if you could show at least 2 during your session.
Okay. I haven't downloaded all of them. Andrew.
I wonder if Andrew can help. Are you there, Andrew?
Yes, I can.
Andrew, are you able to play both from your end then?
Yeah, I'll grab them down and I can play them through here during the break if that's helpful.
We'll play it at 12:30 if that's okay. So we have Jimin, and was there anyone else in particular?
Yeah, I think it'd be great if we could play 2, maybe 1 when you come back. 1 before you have a break and 1 when you come back.
Sure. So I'll play Jimin's one now then. Excellent. So we've got a nice little clip that has been put together by our generous volunteers at UBS. Let me try and, so I'm going to have to stop my share here. I'm going to stop share. And I need to open up GMN's clip. And I'm going to start sharing here now.
What time do we want everyone back?
At 12:30. So one time. Andrew, have I got you there, Andrew? Doesn't look like I'm able to share my second file on this end.
Yeah, that's okay. I will. I'll come back in a little bit, and I'll have all the videos, so I can actually share them from this end if that helps.
Fabulous. All right. Thank you very much.
No worries.
Hello, Skyline students. I'm Jamin, and I work in the investment bank technology sector at UBS. My work involves software programming and helping with business analysis. So I studied in New South Wales for the HSC about 2 years ago, and I enjoy taking maths, English, chemistry, and physics. There weren't any specific subjects which led me to my role. Rather, none of my subjects were economics or business related. And so, my advice to my year 12 self would be to make sure to eat well and sleep well, and
make sure to keep that diet nutritious, because in my HSC period, I was mostly at home and had to be responsible for my own food. And lastly, best of luck. Thank you.
Hi, my name is Alicia and I'm an investment banking analyst at UBS. And I'm a graduate this year, so it wasn't too long ago. I was also in year 12 doing exams, sort of wondering what university would be like and what my future career might entail after university. And I think the best advice I ever received from one of my teachers at school was just to keep doing things that you enjoy and genuinely like. You'll always be the most motivated to study for those things and try really hard at them. So in year 10, 11, 12, I did economics and accounting, really liked them, which led to me doing a Bachelor of Commerce at university, through which I found I liked finance, which led to me applying for an internship at UBS and now being a graduate. So yeah, I just give everyone that advice. Make sure you really enjoy what you're doing, and best of luck for your exams. I'm sure you'll nail them and have already been studying really hard for them. So good luck.
Thank you to the generous UBS volunteers for those lovely messages. All good. Andrew, are we okay to share from my end?
Yes, absolutely.
Thank you very much. So I'll start sharing my screen again. And can everyone see that screen?
Yes.
Great. All right. So let's keep moving, folks. So I've got about half an hour before our lunch break. And I've left about 2 hours for financial maths, because I understand that that's the area that most people need help in. So if you have anything that we've got, we need to cover in time series, we'll pick up a few of that at the end as well. So features of a time series, very common style of questioning. We look at overall trends. So you can have an increasing trend over here or a decreasing trend. And what we would if you've got both of them in the same type of question, you would say that we can see that there is an increasing trend up until a certain point, and then that it changes to a decreasing trend overall. Keep in mind, you could have two of these features at the same time. So you could have a seasonal but with an increasing trend. Now, a lot of people confuse themselves between seasonal and cyclical. The difference or the best way to recognize this is that cycles happen over a longer period of time, so longer than 1 year. And seasonal, with seasonal trends, you'll see that it happens within a year, right? So you'll see, we'll look at some examples, and I'll sort of help you distinct between the two. Structural changes. So, for example, let's say we've got a burger shop, and generally we have 5 people flipping burgers, but all of a sudden, 2 people resign from work. The number of burgers that are produced per hour would tend to drop, right? So that's like a structural change, and the easy way to explain that. This could be the same example. Let's say, you've got a general trend, but this is a daily, this is the number of days and the number of burgers. On one of the days I get sick, I don't rock up to work, and the number of burgers that are produced drops as well. So that's like an outlier. Like I said earlier, it can be a combination of these things. And anything that doesn't apply to any of these features that I've discussed, that would be an irregular pattern. So let's get right into it. Briefly describe the general trend in the data. That's really easy. So what do we got? 2000 is 3,900. So somewhere there. Excuse me. And then you've got, okay, so it looks like it is an increasing trend, right? Pretty simple trend. Let's see. Okay, what about this question here? What would you say this here is? Can I get you guys to have a look at it? Pay close attention to the X variable or the X axis that we're talking about? What would you say this is? Come on, guys, time to respond. So people are saying it's a cycle. It's actually not a cycle, because if you look at this, this is just years, right? Remember I said you'll see the patterns repeating within years. So that makes it a seasonal, right? However, it's seasonality, but it's not consistent across. So we've got seasonality with some irregular fluctuations. That's what we're seeing. Okay, so it's C. So great for those that manage to recognize that. So what would you say? Let's see if we can find, what about this one here? What would you say this one here is? Ooh, we've got a range of different answers. So if you look at this, this is also what? Within years, right? Can you see that? It's increasing in terms of years. So we've got an increasing trend, right? Right? Can we say it's irregular fluctuations? Ooh, I can't say that it's irregular because there's a general trend that's appearing. So we've got a seasonality. Okay, very good. Let's see if we can find something that's cyclical. Oh, doesn't look like we've got any of them. And these are quarters. So the difference between this, if you look at this example here, right, this wouldn't have been seasonality if it wasn't month number. So if it was, let's say, the year 1960 and the year 1970 and the year 1980 and so on, in that case, that would have been a cycle. Okay, everyone okay with that? Good to go? Brilliant. So let's move on to the next concept, smoothing. All right. So when it comes to smoothing, guys, there are a couple of things that they will test you on. You've got 3 mean, 5 mean, 3 median, 5 median, and finally 4 mean with centering. So a lot of the time people manage the mean stuff except for the 4 mean centering. So let's say if I was asked to find the 3 mean with 3 mean for March, okay? So what I do is I go, including that value, I'd go above, and one below, right? Because that's what makes my 3 data values, okay? So one thing to also remember is that when you're doing 3 mean, these bottom 2 will not have a data value, right? So you would add these 3 and divide by the 3. Does that make sense? Are we good? Right? Really simple stuff, right? If I was asked to find the 5 mean for June, right? So 5 mean for June, I would say, well, that's 18, which is my inclusive, 2 above, which is 5 plus 22, and 2 below, which is 13 plus 7 over 5. All right? Really straightforward, right? Recognizing the data values that we need to include. We need to have 5 including the data value, so we'd go 2 above and 2 below. Now, 3 median and 5 median, it gets a little bit trickier. So once again, I need to mention that for 5 mean, these 2 data values and these 2 will not exist because we don't have enough data values when you get after October to have 5 data values, right? So for 3 median, what we do is let's say I'm trying to calculate the 3 median for February. So I'd go to Feb. So I've got the 10, the 12, and the 6, but I'd write them in order. So I'd say 6. I'd write 6, 10, 12, and then the middle value is the 10. So I pick 10. So the value the 3 median value for February would be 10. So can I get you guys to tell me what the 3 median value for let's do August, please. What's the 3 median value for August going to be? 9. Brilliant. So you said 7, 9, and 13, and we know that's going to be the 9. Really easy. Okay. How about if I wanted the 5 median value for May? So to make it easy, we would go and recognize, which set of data we're talking about. And that's these guys, right? So I've got 5, 6, 13, 18, 22. So I know my data value should be 13. Okay, so hopefully you guys are feeling comfortable about those stuff. I don't have to spend too much time on this, right? Be good? Cool. So then we've got 4 mean smoothing with centering. Now this gets a little bit trickier. So for instance, if I was asked to find me, okay, so for 4 mean smoothing for me, I go with, well, I say 2 above, including +1, I say, right, plus below, right, divided by 4, and I go 2 below plus including +1 above divided by 4, right? Let's see what I'm talking about here, right? So I would add 2 above me plus including, so that's gonna give me a value round about here, right? So because that's gonna be in the middle of these 4 guys, so that's gonna be 6 plus the 5 plus the 22 plus the 18 divided by 4, right? That's gonna give me a value between April and May, so that's still not good. And then we're gonna go 2 below. 2 below, that's gonna be 13 plus 18 plus including, which is 22, plus 1 above, which is 5, right? I should actually
question. For the 3 mean smoothing, why do you not include the first value in this case? Jan.
First value, I'm saying that we won't have a value for this one. I'm saying that we won't end up having a value for that for January, because for me to find January, I would have needed the 10, the 12, and the value before January, but I don't have that value. Does that make sense? Whoever that asked that question. Jen. Okay. All right. So over here, I said 2 below. So I'd said 13, 18, 22 plus the 5 divided by 4, I should have said, right? I'd divide both of these by 4. Then once I've gotten those values, I would add them together and divide it by 2. Okay, so I would have to go and calculate 6 plus 5 plus 22 plus 18 divided by 4. That gives me a 12.75. And I go 13 plus 18 plus 22 plus 5 divided by 4. That's 14.5. And when I add those two, 12.75 plus 14.5, and then divided that by 2, that's when I would have the value for me, which is going to be 13.625. Oh, 635. Is it Raj? One of us would have made a careless mistake, but I'm pretty confident I've done that bit right. Yeah, 625. Fabulous. Is everyone okay with this? Yep. Yep, fantastic. All right. That's really good to see. All right. Moving on, we've got smoothing and when we have to smooth values graphically. So to smooth values graphically, what we do is we trace our values along the x-axis and then we go, okay, well, what's in the middle of these 3 data values? So I know it's going to be this one, right? And then I'll trace upwards and what's going to be in the middle. So I'm going to come across this one first. I'm going to come across this data value. So the median value between when I do this using median smoothing, that point there is going to be the median value. Okay. Once again, let's have a look at this. The next question, we're moving across. So that's going to be my middle value. And then when I'm moving up, who am I going to come across in the middle? I'm going to come across this data value here, right? So we've got the median value would be up there. All right. Let's have a look at this here. Now I got, imagine this was 1, right? And this was a 2, right? So if I consider my x values, I've got 1, 1, 2, right? So the middle value is going to be the 1. Imagine my y values here. This is 1 and this is a 3. Then I would have had a 1, 1, 3, right? And what would have been the middle would be the 1. And that would mean that my median value is going to end up being this one here, okay? Because it'll be 1, 1. Cool, so let's have a look at the style of questioning that we'll have to do for smoothing. So we've got, all right, so they're asking us to do 5 median smoothing. Okay, so 5 median smoothing. Now, the first thing to remember when we're doing 5 median smoothing, guys, I said, remember the top 2 values and the bottom 2 values will disappear because we don't have enough data values to find those medians. So in this case, December, right? These guys should disappear technically, right? Does that make sense? So I can easily eliminate this. I can eliminate C, and I can eliminate E as well. So now I'm tossing up between B, right? I'm tossing up between this guy and this guy here. So I want to go and look at a value that is distinctly different between these two solutions. So I can see that September, for September in this question, they're saying that is a 7, right? They're saying September is a 7. In this question, September is supposedly a 5, right? Yeah, September is a 5. So I would go to my solution here, my question here, and I'd look at the 5 data values that represent September, right? These are the 5 data values. Everybody okay, right? Now, if I've got 5 data values, which value is going to be my middle, guys? If I've got 5 data values, the third data value should be my middle one, right? So I go, I'm trying to find what that is. I'm going to come across that data value going up first. Then the second one is that. And the third one, oops, I think this is too thick. This margin. So I'm going to come across this data value first, then that data value second, and that data value third. And that third data value is actually how much? 5. Okay, so it gives me my B. Everyone's comfortable with that, tracing mechanism. So technically, you don't have to go and look at every solution, guys. We can easily eliminate a few of these solutions by being savvy about it. Okay, so let's have a look. I mean, how much more have I got to go? I've got quite a few. We've got, okay, I'm going to have to come back after the break to the stuff. So we'll just continue as per normal. And let's do one more example of this. So let's say they're asking us to find 5 median smoothing has been used to smooth the time series plot above. The first 4 have been done. Complete the 5 median smoothing for the rest. Okay, so they've done for number 6. Now we've got to do for number 7, right? So go for number 7. The values around that would be, I'm looking at these 5 here, right? So going up, the middle value is going to be 1, 2. Can you guys see this? 1, 2, and 3. So that will be here, right? So I'd rub that off, rub this bit off. And then I'm looking at my next set of data. I need 5 data values around the month number 8. So I'm talking about these. Month number 8, this bit here. And going up, I've got to find out who's going to be in the middle. So I've got 1, 2, 3. So that's going to be that value there, right? And then I've got month number 9 that I've got to look at. And the 5 data values around that would be this bit here. And going up, I've got 1, this one here, 2, and that one there, that's 3. So that's going to be that, right? So that's going to be the third value that I'll come across. which means for month number 9, I would end up with that there. And I cannot have a value for, sorry, for month number 10, that will be my answer, which means I can't have a value for 11 and 12 because, as we said earlier, the last few values would cancel off. So I know my smooth data, 5 median smoothing line would look like that. Are we okay with that concept? Yeah, good. Thank you so much for actively contributing and responding, guys. That's the best way to get the maximum from these sessions. Cool. So let's move on to seasonal adjustment. I've got a few notes here. Pretty simple stuff. The sum of all the seasons, seasonal indices, should equal to the number of seasons. So if it was months, if the seasons were months, how much should it add up to? It should add up to a 12. If the seasons were quarters, it should add up to a 4. If the seasons were days, it should add up to a 7, and so on. We've got equations to deseasonalize data. We won't have to do, unlike in the SACs, we won't have to do all of these calculations. A lot of the times they'll only use one of the concepts. So I guess we'll jump right into it. We've got interpreting seasonal indices as well. So if you've got a value that is greater than 1, in this case, I've got 0.3 that is greater than 1. So we would say on average, the value for summer is expected to be 30% greater than the seasonal average, right? If you've got a value that is less than 1, for example, I've got 0.75 here, all you need to do is you go 1, take away 0.75, and then multiply that by 100%, right? Nice and easy. So in this question, I would say on average, the average value for winter is expected to be 25% below the seasonal average. These two, yep.
What if the question gave you 11 months and is asking for one of the missing indices?
Yep. So all you do is you total up all of them and subtract it from the 12. Okay, so we'll have a look at some examples as well. Guys, I didn't see this equation in the textbooks, so I think this is definitely worthwhile noting. A lot of MCQ questions where they ask you to correct for seasonality, or they'll say, what would you need to do to correct for seasonality? So this is what you would follow. If you've got a seasonal index that is greater than 1, you go that value, take away 1 over that seasonal index, and then multiply it by 100%. That is what you would have to do. That's what you'd have to reduce the data value by. If you've got a seasonal index that is less than 1, you go 1, take away that seasonal index over the seasonal index, multiply by 100%, right? That's how much you would have to decrease the data value by to correct for seasonality, okay? So, but the total is 11 months and you only have 10 values. Mahara, I think if you can send me a picture of that type of question, we'll take it offline and I can cover it during one of our lessons, okay? So this is what I was talking about. How would you correct for seasonality? You've got the seasonal index for winter is 1.25. So I said you go 1.25, take away 1 over 1.25, multiply by 100%, right? So what's that going to give us? 1.25 minus 1. Divide by 1.25, multiply by 100. That gives me, so I need to what? Oh no. Sorry, folks, can you guys change that? That needs to be increased by, okay? And that's decreased by. Can you folks change that, please? That's an error. Are we good? So in this case, because the seasonal index was greater than 1, you would have to reduce by 20%. So you would have to reduce it by 20%. Okay, so that's a really good equation to have it in your notebook that you're using. How about this one here?
Questions openly state that we have to correct seasonality.
Sorry, they would say correct for seasonality. Yes, they would state that in the question. So
Thanks.
is this the question that you're referring to, Mahira? It's got a month question. The seasonal indices for the first 11 months of the year for sales of sporting equipment is given. Find the seasonal index for December. So what would we do? We would total this up and subtract it from 12. Okay, so that's really easy. So total them up. So you've got 1.23 plus 0.96 plus 1.12 plus 1.08 plus 0.89 plus 0.98 plus 0.86 plus 76 plus 76 plus 95 plus 1.12. And one takeaway, my answer should, what have I done there? 0.95, 0.76, 0.76. 12 takeaway, the answer should be 1.29. Okay. Then the next question is asking us to find the deseasonalized value for May. So to deseasonalize, I've given you guys the equation here. You go actual figure divided by the seasonal index, right? So the actual figure has been given to you for, that's 213,956. Needs to be divided by the May value, which is 0.89. So if you go 213,956, control divide by 0.89, control enter. That gives me a 240,400. Okay, so we are gonna take a lunch break, and we'll come back to seasonality afterwards. I'll do about 10 to 15 minutes before we get started with our financial maths. Guys, take a proper break. Try and stay away from the screen. Go out there for a walk, get some fresh air. And yeah, what was that link to the survey? I couldn't find it in the chat. Not a problem. I will send that through to you. And yeah, I'll see you guys back here at 1:30 p.m. Okay, so hopefully everyone's had a good lunch break, had some time to get some fresh air. Before we kick things off, I want to make sure everyone's had a chance to take a look at this table that I put in front of you. So this is basically a breakdown of what I would suggest is an ideal time to be finishing an exam, and obviously like the max or the upper boundary in terms of time you would have available. So if you look at it on the left-hand side, I've pretty much done the calculations for you for exam 1 and 2. If you're, let's say you're doing the financial section, for example, and you're between 9:45 a.m. and 10 a.m., that's perfect. That means you're in a pretty good position. If you're between 9:55 and 10:15 a.m., that's still decent because that's like the absolute maximum. But you shouldn't be spending, given that this is this is given that you'd be going in order of the modules. So starting with the stats, then financial, then the module. So I would say that if you're done with financial by 10:15, that's reasonable. So you don't want to be pushing it too far as well. Cool. All right, I think I've got someone that's not on mute. Who is that? I've muted Sarah there. Sarah's got some music going on. Cool. All right, guys, let's get started. Because I've got 2 hours allocated for financial, I'm going to go and finish the statistics, the seasonal indices content. So we've gotten up to this point. We've done a fair few examples. We've done the, identifying the missing value. We've done questions relevant to increase and decreasing. Let me see if there's any sort of changes. I think they're all quite the same, so that's reasonable. These are all similar. All similar. So let's move into predictions. When it comes to predictions, it's pretty much the same. What we're doing is we're coming up with a regression analysis or regression equation for a predicted seasonalized data value. And we use like a season number to predict. I'll go over an example in a moment for you. However, to forecast the actual data value, we would have to take that predicted value that we get from that line, from that equation, and multiply it by the seasonal index for the season. Okay, so that's something that you will have to keep in mind. Let's have a look at a few questions over here. So we've got, they're asking us to use the variables GDP and time, and write down the equation of the least squares regression line. So for this, you would obviously call it TX, because that's going to be your X variable, and GY, because that's going to be your GDP, is going to be your Y variable. And what I would do is I would go and plug this into my calculator. It's a time series. I don't have to make any changes at this point. That's pretty straightforward. So you go and say list in spreadsheets. Your X variable is going to be TX. Enter all the data values going down. So I've got 0, 5, 10. Right. So you guys understand what I'm doing here. 0, 5, 10 going down. And then I would have 20,900, 22,300, and so on going down like that. Right. So 10, 15, 20, and 25. I've got my Y variables, which is going to be GY. And my values are 20,900, 22,300, 25,000, 26,400. Guys, get your calculators out and make sure you're doing these because you want to be making errors now, right? Making errors and recognizing your errors now. No better time to be doing that than about 7 weeks away from exams, right? So we've got menu 6.1, and I'm going to do a linear regression. My X data values. So I'm going to do linear regression. My X values, oops, what's going on? Are you seeing my screen, everybody? Yep. I've lost my chat. What's going on? Can you guys see my screen? Yep, great. Sorry about that. What's happening? Here we go. Apologies. So I was doing a linear regression. My X list would be, in this case, TX. My Y list would be GY. So nice and easy to recognize because I've labeled them properly. And obviously, I don't want to have to keep deleting my variables because in the exam, we won't have time to keep entering them from time to time. So it's easy when you've labeled it for each question in a unique way, right? So get my least squares regression line. What are they asking for? They want it, they haven't mentioned any decimal places, have they? Take time as explanatory, nice and easy. Cool, so basically what we would say is that GDP is gonna be equal to 20,000, which is my A value, plus 524 times time. Okay, nice and easy. The least squares regression line in part C above has been used to predict the GDP in 2010. Okay, 2010. Now they're asking me, why is this considered unpredictable, unreliable? Can someone tell me what we discussed earlier about when we're predicting using the regression lines? What type of prediction is going to be unreliable? Come on, folks, don't be shy. Yep, when it's an extrapolation, right? So you would say the year 2010, right? The year 2010 is outside the given data values for time, yeah? For time, and is an extrapolation, yeah? Nice and easy. Let's have a look at this. These aren't quite the questions I'm looking for. Let's have a look. These are all trying to find equations. Well, it doesn't look like we've got that many DCs and lies in to try and predict questions here. We might just do one more example. Folks, let's do this one. Can I get you guys to give me what the A and B values for this question is going to be, please? So plug this on your calculator. And happy for you to direct message me if you've got any doubts. So if it was up to me, I would call this MX and NY. Okay, so really easy to identify your variables and double check your values and so on. All right, I'll give everyone a moment. Cool, so I've got a solution here. Can someone verify that this is the right answer? We've got 7.79, how many decimal places? 3 significant figures, very good. And then I've got 1.63, brilliant. So I've got 2 people sending me the same answer. Sorry, 3 of them, fantastic, right? So hopefully you guys are comfortable with that. Once again, they've asked us to draw the line of the least squares regression line. So that's pretty easy. You just go and put, 2 coordinates like I explained to you guys earlier. So you got the 7.79 here, which you can easily use. So that's about roughly around 8. And then you go and sub in a coordinate. For example, you might sub in something like 5. So you would say 1.63 times the 5 plus the 7.79. Control enter, that's 15.94. So 15.94 at 5, that's roughly a 16. And then you'd place your ruler and draw the line like that. Okay, everybody comfortable with that stuff? Fabulous. All right, so let's move on to financial maths, guys. This is really what I'm looking forward to covering with you guys. What I've basically done is I've tried to help you guys recognize what set of rules you'll use for each type of question, okay? So on the left-hand side here, I'm not going to annotate too much. On the left-hand side here, you've got linear growth and linear decay, right? They will both use a similar set of equations, right? In both cases, you have to calculate the common difference, right? The value, the D value here, as you can see. I might use pink for clarity. So you've got to calculate the value D, as you can see, right? In both style of questions. How do you know they're asking for a linear growth or linear decay? these are the words that you're looking out for. Okay, so these are going to be your trigger words, right? The moment you see simple interest, you know it's a linear growth question. The moment you see the word flat rate depreciation, you know it's going to be a linear decay question. Okay, we've got a recurrence relation. Everything that I've highlighted in yellow, those are the values that we will have to change according to the question. Okay, so yellow means change according to the question, okay? Because those will be values that you would have to determine by using your calculator and computing them. Everybody okay on the left-hand side here, right? So you can see that, you know, a linear growth is going to have a positive D, a linear decay is going to have a negative D. We've also got nth term, right? We're talking about values. If they say, you know, what's going to happen in the 13th year or 15th year, it's not practical for us to keep adding or subtracting one by one. Instead, we would use the rule here for the nth term, okay? We'll have a look at a few examples like that today as well. On the right-hand side over here, I've got geometric growth and geometric decay. I'm not sure if that's clear enough for you guys. Both of them, you'll see, have an R value, okay? They both have, well, that's really thick. Both of them have an R value, as you can see there. When it's a growth, it's going to be 1 plus R over N. The N there is representing how many times the question will be compounding, okay? Now the N over here, although it's not a compounding situation, sometimes, you know, when I'll do a few examples for you as well, sometimes you'll find that they'll say, well, what's happening on a monthly basis, right? Or, you know, how much is the value going to go down by on a monthly basis? So they could still do that for flat rate and simple interest rate as well. Then for geometric decay, you've got 1 minus. And the trigger words that we're looking for, the moment you see compound interest, we know we're talking about a geometric growth scenario. So this is the bunch of equations that you will be using. The moment you see the word reducing balance depreciation, you know this is the bunch of equations that you'll be using, okay? And in terms of the equations, you've got the nth term is quite the same for both of them. And you've got the recurrence relations also quite the same for both of them, okay? It's just that R value that keeps changing for each of them. Once again, anything that's in yellow, we have to change according to the question, okay? So can I get a thumbs up or a yes if we are sorted for us to move on from this note here? Brilliant. So we've got like a nice little summary there, and you know what to look for to try and identify which set of equations to use. Okay, so these are really baby questions, so I'm not going to spend too much time on these ones. I want to keep going through the notes, and we'll try out some more difficult questions. Writing and interpreting linear recurrence relations. So we've got reducing balance loans, where you're going to make a payment. With examples, with questions like that, the payment is given to you generally. They'll say they're going to make a monthly payment of so-and-so. So that's going to be your D value. More often than not, you'll have to calculate your R value. And this is the equation that you can, that you have to use for it. Quick question. Can we use nth rule? Can we find nth term for a reducing balance loan using an equation? Can we find the nth term for a reducing balance loan like this using an equation? We cannot. Okay, we cannot. So we have to use financial solver for that style of question. Okay. Then I've got the 4 graphs for you, really easy. If they say it's simple interest, you will see a starting value, right? You'll see a initial value of V0, and then you can see that the increments are consistent. So we've got a common difference that's increased. If it's flat rate depreciation, you've got your initial value here, and you can see it's a constant decrease, right? So the common difference is going to get subtracted. Pretty straightforward. For compound interest, we can see that the amount that it is increasing by keeps increasing, right? The amount that is going up by keeps increasing. So that's compound interest related questions. And for reducing balance, you can see the amount that it is decreasing by keeps decreasing. Okay, so the difference keeps decreasing as we go across in time. So that's just a bit about the notes. All right, so I think this is a reasonable bunch of questions. Let's have a crack at these ones, guys. I might just zoom in a little bit so there's a bit of clarity there. Which of the following recurrence relations will generate a sequence whose values decay geometrically? Now, decaying geometrically meaning consistently going down by a common ratio, right? So just pop the answer in the chat, guys. What would you say is going to happen? This is going to be a common difference, so that can't be the answer. This is a common difference because we're going to keep adding 100. And this is a geometric decay, isn't it? Right? Because the value keeps decreasing because we're multiplying by 0.65. Oh, some people are saying it's D. Why is that? It can't be D. Why can't it be D? Because that is showing us a growth, right? Yeah, this is saying that it's going to increase by 6.5 fold. Okay, so it has to be C for decay. Is everyone comfortable with that? Yeah. Mitch, did you understand what I meant by that, buddy? Awesome. All right, let's have a look at question number 20 here. Rohan invests $15,000 at an annual interest rate. Okay, look at that. They've said annual, and they've also said compounding monthly. So when they say compounding monthly, I got to remember that my N is 12, right? Let Vn be the value of the investment after N months, a recurrence relation. So nice and easy. We know V0 is going to be equal to 1,500. And I said Vn plus 1, okay, is going to be equal to R multiplied by Vn. So Vn is that. I need to calculate what my R is. R is going to be equal to 1 plus 9.6 over 12 over 100, right? So that I've got to make sure I'm dividing by that 12. So I've got a fair few of you guys saying B, and 96 divided by 12 is an 8. So 0.8 and then divide by, yeah. Okay, so that's going to be a B. Everybody okay with that? Yes? Good. All right, let's have a look at question number 8 here, right? So Hugo won $5,000, won $5,000, they're saying. So that looks like it's going to be our initial value. He's deposited the money into his savings account. So now we got to find out what type of savings account this is. Recurrence relation is what we're looking for. By the looks of it, it looks like it's a geometric growth, right? Because it's a 1 plus R question. Using a different investment strategy, he could deposit $3,000 into an account earning a compound interest of 4.5% per annum, compounding monthly. So the moment you see the word monthly, you gotta be careful about what's going on. Now they're talking about making additional payments of $200 at the end of every month. Cool. They've given us the monthly interest rate, which means we don't have to calculate anything. I might just double check that. So what's that saying? That's saying we've got 4.2 divided by 12. Is that a 0.35? Perfect. They've given us that. So Vn, right? This is one of these questions. I should have said this is a reducing balance loan, but we've got annuities. Whoops. With payments into account here as well. And that would be V0 equals principal. And Vn plus 1 is going to be R multiplied by Vn. It'll have to be the plus D, right? Because I'm going to contribute more money. Okay, these are like our super savers. Okay, people that don't want to withdraw money, they just keep saving money. So Vn, so I've got to say, I need to write my recurrence relation. So first things first, I've got to say V0 is equal to $15,000. Nice and easy. Vn plus 1, right? Remember, I got to calculate my R value. Now my interest is going up, so it will be 1 point. What should I say that is? That's going to be 1 plus 0.35, control divide 100, control enter. That's 1.00. Sorry?
Do we do TN?
Yeah, sorry. Thank you. Very good. So I've got T0, and that's Tn plus 1. Multiply by my Tn. And then on top of that, I'm making a contribution of $200. So I'd say my positive 200. Okay. Is everyone okay with that? Good pickup, folks, right? Can't assume the question. We've got to always read the question. What is the total interest Hugo would have earned after 6 months? Now they're asking for interest Hugo would have earned. Okay. Now we could use the financial solver for this. But because I'm going to cover financial solver later, what I would like you guys to do is I'd like you guys to use the calculator, right? Determine T6 first, right? So using recurrence, determine T6 to find interest. Interest will have to be my value at the end of the 6 periods or 6 months, take away my value at the start. Isn't that right? Because how much, whoops, sorry. Was that going to give me... No, sorry. So find out T6 for me, and I'll tell you what we need to do to find the interest. So can someone tell me what T6 is going to be first of all? I'd have to subtract T0, and I would have to subtract plus 6 times the 200 that I've been contributing into the account as well. Raj, so is that T6 for me, mate? We got 16,528.3. Someone said 3.1, someone said 3.2. What is it? 3.2, fabulous. And then that's going to be $16,528.32 minus T0, which was my initial investment amount of... Where did I put my 15,000? Why did I say 15,000? Whoops. Sorry, I think I've made a careless mistake there. T0 should be at 3,000, right? That's my initial amount. Sorry, guys. I'll do this myself. So that can't be it. Oops. Let's go T6. There's obviously a fair bit of pressure when everyone's looking. So let's do, what's this? 1.0035 multiplied by the 3,000. All right. Who's this? Liam. Thank you. So I've got, what's this? 4274.10. Brilliant. So 4274.10 minus, that would be the 3,000 plus how much more are we going to contribute? 1,200, right? And essentially that would end up being, what's that? 4,200. So $74.10. Everybody okay with that? We good? Excellent. All right, let's move on to this question here. The purchase price of a car was $26,000 using reducing balance method, right? So the moment you see that word, you know which set of equations we need to use. It's depreciated by 8% per year. Nice and easy. So you'd go and say 1 minus, let me write this a little bit clearer. I'd say 1 minus 8 over 100. Right, so that's my R value, and that's going to be equal to 0.92. And it should be, V0 equals my initial, right? So I know that already. So that I would say that's $26,000. And then I'd say Vn plus 1, or Cn plus 1 in this case, is going to be equal to, we've got 0.92 times Cn, which is my previous term. So I would end up with A. Okay, nice and easy. Let's have a look. Let's have a look at this graphical question here, right? So we've got Juanita invests $80,000 in a perpetuity. Now, I almost feel like I should go and talk to you guys about this concept here. Give me a moment. Let me get to the calculator stuff. So I've got a few really good notes about each of the different scenarios, and then we'll go back to questions afterwards. Okay, so can you guys see this clearly? I'll just talk about each of the different scenarios before we go and jump into some questions. Okay, so in a reducing balance loan, what we do is we get a massive lump sum of money from the bank. Okay, so maybe I'll zoom in and show you just reducing balance. And then what happens is we get charged a certain amount of interest, and we will pay back some interest as well as a part of how much we owe, right? So that's the principle. So charge interest, pay back little more than the interest. Charged interest, pay back little more than the interest. So that's what I'm trying to say. Let's say you were charged $1, you might end up paying $2, right? Just to give you guys a rough understanding of what's going to happen. Eventually what's going to happen is you're going to end up with no balance, right? Or you might end up in a scenario where you still owe some money. Okay, so if you guys recall, in the financial solver, we've got settings for all of these, right? So when I say capital N is the total number of payments that we're going to make across the entire period of the loan. That will be the number of payments per year multiplied by the number of years, right? So that's what I'm trying to say by N by T. Ultimately, when you're receiving money, so in any occasion, if there's money coming from an institution to you, right, whether it's a loan, if that's to you, that means your present value is going to be a positive, right? Because money is coming into your pocket. That's how we think about it. Okay, if you're going to make a payment to the bank, your payment amounts will be a negative. Is everybody comfortable with that? You know, identifying whether it's going to be a positive or a negative. We good? Yeah, great. So that is reducing balance loans. Then the next thing that we need to look at is interest only loans. Okay, now with interest only loans, a lot of the times people forget that N is meant to be equal to 1, because the amount of interest that we will be paying back, or the amount that we will be paying back, is always going to be based on the amount that we owe at the start of the period. Okay, so N doesn't need to change. Our present value is going to be a positive because in the interest only loan, we're going to receive a large lump sum of money. Look at this question, right? In this diagram here, I've said, I get charged interest, I pay that interest back. I get charged interest, I pay that interest back. Unlike before, where I was paying $2 each time, here I'm only going to pay $1, right? That is that interest amount that I owe. Is everybody okay? Yes? Now, this could go on until infinity, right? Or eventually I will have to pay exactly how much I would have borrowed back, right? Which is why when we're doing interest only loans, right, or questions relevant to interest only loans, these two guys will end up being the same value. Okay, the only difference will be a positive and a negative. Yes? All right, excellent. Now, interest only loans and perpetuities are similar but opposite. Okay, funny way to say that, right? So perpetuities, N is once again the same. What we're saying is going to happen in a perpetuity is that we are going to earn that money, the amount of interest that we receive. Let me say that again. The amount of interest that we are going to earn, we're going to receive as payment out. Okay, so that's the kind of question that they use for further. Because at the start, this is like an investor, right? So let's imagine you've got a really rich person. What they'd do is they'd go and put a large lump sum of money in the bank. The bank would, calculate interest. They will pay back that interest amount. Calculate interest, pay back that interest amount. Calculate interest, pay back that interest amount. This can go on until infinity, but at the end of the day, you are still entitled to that initial lump sum of money that you put in the bank. Everybody okay with that? Yeah, fantastic. That is why we will notice that in perpetuities as well, the relationship between these two guys is that they're both going to be the same. They're going to be equal to each other. Alrighty. Moving on to annuities now. The annuities is, it's similar to a case where it's, let's talk about the difference between a perpetuity and an annuity. In perpetuity, I would say money, you've got payments coming in forever, right? In an annuity, your money will run down to a zero. Okay, right? Essentially, it will run down to a zero. So in this case, if you look at this example here, what I'm saying is I'm going to go and deposit a large lump sum of money in the bank. The bank is going to calculate interest, but it's going to pay back some of what I have put into the account as well in terms of payments, right? It's like what happens in our reducing balance loans, but the opposite. Okay. Same case here, right? So eventually what will happen is it'll run down to a zero. I've said here it could end up being a positive because ultimately there could be a scenario where at a certain point in time, you still are meant to receive that money back. Okay, that's why I'm saying it would end up, it could potentially be a positive as well. And then you've got the super savers that I was talking about earlier. This is the annuities with payments into account, right? So people, what people will do is you've got, a person going and depositing money into the bank, right? The bank is going to calculate interest. It's going to keep it. We're going to make more money. We're going to deposit more money. It's going to calculate interest, keep it in the account, but we're going to keep paying more. Ultimately, what's going to happen is at the end of this all, we are eligible to receive a large lump sum of money. Everybody okay then? Yeah. Cool. Any concepts here? Any of these? I know I went through that really quickly, but you've got these diagrams to try and help you understand what's going on. So please reflect on them later. Any of these that you want me to sort of elaborate a bit more on, you can just message me now. Looks like everyone's okay. Good. All right. So that's that. Now, if we think about principal amounts, right? If we think about the principal amount for this, the principal amount will end up going down because ultimately how much we owe is going to keep decreasing, right? Because we're paying some of the lump sum. If you think about the principal amount for this, how much we would have borrowed, that will remain the same until that final payment that we make, right? Where we have to pay that lump sum back. If you think about the principal amount for this question in a perpetuity, quite the same, right? We're gonna keep most of the money in the account until we make that final withdrawal. When you take an annuity, guys, what's happening there? Once again, the principal amount will go down because we're receiving parts of the principal as a payment. And then annuities with payments into account, what's going to happen with our principal? Our principal is going to keep, not principal, what's going to happen with our value? It's going to keep increasing, right? Because we're going to constantly keep putting more and more money into the annuity. Are we okay with these diagrams? Yes, if I say this is VN, that will be N, okay? So just thought it'd be worthwhile going over that really quickly. We'll head back to our questions, guys. Sorry about having to jump up and down because sometimes it's difficult to cover all the concepts, right? So let's have a look at this. Where are we? Sorry. Let's go back to the section where we left things off. Where are we? Here we go. All right. So now this should be a piece of cake for us. Let's have a look. It is invested in a perpetuity, folks. Give me the response. What should my answer be? What's happening when it's a perpetuity? We know that principal is going to remain the same. Brilliant, right? So everyone can easily identify that that's going to be a B. Let's have a look at this question, right? So they're asking us how much money was initially deposited into the savings account. That's V0. Can you guys hear me? Thought I froze for a moment. Yep. So initial amount is $15,000. Nice and simple. What is the annual percentage? So looks like this is after N years. That means they haven't compounded it at all. So what would our annual percentage be then? Guys, what would you say my annual percentage is? It's this guy here, right? So what's that? That's going to be just the 4%. Nice and simple. Okay. Let's have a look at these questions here. What would you say the answer to 2017 question 18 is? So note it is a savings account. It is a savings account, compound interest, 3.1% per annum, right? And they're saying it's compounded annually. Okay, so they want us to, hang on, compounding annually, perfect, right? So they want us to find the value after n years. So what should that be? Looks like people are managing this. So R is going to be equal to 1 plus my rate, which is 3.1 over 100. There's no n in this case, so that's going to be a 1.031. Pretty simple. So that would be my answer, B. Okay, cool. Think that's fine. Let's have a look at this question here. Question number 8, right? Now, with this style of question, guys, we could do perpetuity, and we could do perpetuity. Let me write this as a note. Perpetuity and interest-only loans. Calculations without the calculator, as in without using financial solver. And the equation for that is D is equal to R over N over 100 multiplied by V0, right? Where D is going to be your deposit or payment amount, right? That's going to be your deposit or payment amount. And R is your rate per annum. And N is number of compounds per year, right? Okay. Now this can be this can be used for any style of question, this equation. However, there are certain questions that you cannot use the financial solver for, and those are questions where you're not given the initial amount. Okay, so if they haven't given you V0, there's no other option other than to use this equation. Is everyone following what I'm saying? Because you can't have two unknowns in your calculator. All good, right? Brilliant. So I'm trying to do this question here. So they're saying 80,000 is invested in a perpetuity. That's 80,000 then V0. And then they're saying provide an annual price of $3,000. That's the payment amount. And they want us to find out the annual rate of interest, right? So that's going to be R, I do not know. N is going to be once a year because it's annual. And then over 100. So I could do menu algebra solve, or I could simply transpose this, right? I could say R is going to be equal to 3,000 multiplied by 100 over 80,000. So can someone tell me what the R value for that is? So 30 divided by 8, 15 over 4, 7 point something. Oh, 3.75. Is that right? Yep, fabulous, right? So that's that. Moving on to 2017 question number 23. Can I get you folks to have a look at this question and tell me what the solution for that should be? So we've got 1, 2, 3, 4, 5 sections. Okay. So what would you say is going on here? They've said reducing balance. I've said that it's reducing balance, nice and easy. So really, like we could easily just eliminate some of our, hang on, piano, right? We can eliminate some of these solutions that we have, right? We don't even have to do anything. It's A, right? Yeah, because it's reducing balance, we can eliminate some of the options that we have there. We don't have to do any calculations for that question. Brilliant. Let's have a look at this one here as well. Now they've asked us to show that the annual rate of depreciation is 8%. Now this is one of those questions where we're actually missing some information, right? So let's have a look. They're saying we've got, it was purchased for $3,000. The value of the snooker table could be depreciated using reducing balance method. After 1 year, it's 2,760. Okay, so basically after 1 year, it's gone from $3,000 to 2,760. Now, if I was to use my equation, I would say, well, n plus 1, right? This is just for explanation's sake. This is not exactly how I would do it if I was to do it myself, right? I know this value is 2,760, right? This would have been 1 minus R over 100 multiplied by the 3,000. Isn't that right, guys? Yeah, right? Yeah, that's how I would have gotten that. So I'm asked to find what R is. You can transpose this and solve for R, right? Nice and easy. So you would say R is equal to, I mean, if I was to show this, I'll divide both sides. So 2,760 divided by the 3,000 is equal to 1 minus R over 100. And I'll just simply just do that on the calculator and say R is equal to 8%. Are we okay with that? Yeah, great. Let Sn be the value of the snooker table after n years. Okay, write down a recurrence relation, nice and simple. So I made that careless mistake earlier where I didn't write what was going on, right? So S0 is going to be equal to 3,000, we say. Sn plus 1, which is my next term, will end up being 0.92 times Sn, okay? Nice and easy. All right. If I just do I get the full mark? Yeah, you would get that as well. That's also a really easy way to show that as well. You could show that it's depreciated by, so the depreciated amount is 240. So you could say depreciation rate is going to be 240 over 3,000 multiplied by 100%. Are we okay with that? Good. Thanks for that, Jeremy. All right. So now I want to gauge how I'm traveling for time. So what I'm going to do is I'm going to get you guys to attempt a question. I'd like you guys to have a read of question number 2017, question number 22 in 2017, and respond to the solution, respond with the solution. I'll just look through my PowerPoint really quickly. All right, so 27 question 2. All right, what would you say the response or the solution for this should be? Let's have a look. So we've got a graph. Does it look linear to us? It's not linear, right? So it can't be anything to do with flat rate, right? So nothing to do with flat rate. Value is going down, so it has to be a depreciation question. So it's not A, it's not flat rate. It could be B, but let's have a look at the rest of the answers. Can't be C because it's not a investment where the value is going up. It is not a perpetuity because we would have ended up with the same in terms of how much interest we would be receiving. It can't be an annuity investment with additional payments made because that would look like it's going up this way, right? So that would be B. Fantastic. So I think we are going okay for time. So I've got about how many slides? I've got about 20 slides to go, and I've got 1 hour and 50. Yeah, good. 15. So great. So let's have a look at 2017 question number 5, folks. By how many dollars is the van depreciated by each year? This is a set answer. We've got, it's going down because it's a flat rate question, right? Remember, D is what they've calculated for us. So they're saying that is 3,375. Speak of which, I really need to stress on something else for you guys. I'm going to go back to our notes here. Over here. How do we identify the difference between reducing balance depreciation and flat rate depreciation? It's all in the wording. For reducing balance depreciation, they will say it goes down by a certain percentage, right? Depreciates by a certain percentage each year. Okay. This would be depreciates by percentage of the purchase price. Do you understand? Okay. Does everybody understand what I mean by that? Right. So for flat rate, they would say it's a percentage of the purchase price that keeps dropping each year. And for reducing balance, it'll be depreciates by a certain percentage each year. Okay, so that'll be based on the previous year's value. So that's going to be a reducing balance one. Sorry, just thought it's worth mentioning. So where are we? We are up to this point here. They're asking for the annual flat rate depreciation for the value of the van. So we could do this using the previous method that we discussed. So that's going to be flat rate 3,375 is how much it goes down each year, divided by the 75,000, multiplied by 100%. Okay, nice and simple. Write your answer as a percentage. And they haven't asked us for decimal places, so I'm assuming this will simplify nice and easy. 3375 control divide 75,000. Does everybody get a 4.5%? Brilliant. The value of Alex's van could also be depreciated using the reducing balance method of depreciation. Okay, they're asking us to calculate the annual percentage rate. So that is R, right? R is 1 minus R over 100. They've given us that R is 0.943 equals 1 minus R over 100. Guys, what is my R value going to be? Huh? What is my R value going to be? It is going to be a 5.7%. Okay, are we okay with that? Are we good? I know it's been a long day, but hopefully you guys are still switched on and paying close attention to this type of question. Cool. Let us have a look. Let's try and see if we've got a question that looks a little bit different to what we've been doing. They all seem quite the same, don't they? How about, let's have a look at this question here, 2019 again. What would you say the answer to that should be? Good. I've got a few of you folks saying it's A. Some of you guys saying it's C. All right. So let's see. Marty has been depreciating the value of his car each year by using flat rate depreciation. After 3 years of ownership, the value of the car was halved due to an accident. Okay, so at 3, something needs to happen. Which one of the following graphs could show the value of Marty's car after N years CN? Okay, so a couple of you guys are saying it's A, a couple of you guys are saying it's C. Cool. The first thing that we need to remember is when we're using flat rate, it's going to look like a straight line going down. Yeah, that's the first thing that we remember. However, this happens for 3 years like this. And then what happens is whatever this value here is going to be half after for the 4th year, right? So for if this was, let's say I've got this is 20, this should end up being a 10. My next value should be a 10. So I got to have a bit of a steeper drop. So it's definitely not A because it's not consistent across the years. It's not B. This can't be it because that doesn't look linear, right? That looks like it's got a bit of a bump. And they haven't mentioned that the flat rate depreciation is going to change, right? They haven't mentioned that the flat rate depreciation is going to change because it could have been D if they said the rate that it was decreasing by changed a bit. So you can see that gradient sort of shifting, right? But they haven't said that, right? So they've said that Marty continued to depreciate the value of the car by the same amount each year. So the gradient should be the same for both of them, right? So it'll end up being C. Fantastic. All right, so let's have a look at 2019 question 7 as well. I'd like you guys to have a go at getting the model for this. So can you guys come up with the recurrence equation for me, or recurrence line? What am I saying? My English is broken today. Recurrence relation for me, please. Where am I? So in 2019. Question 7, I'm up to. $126, $330, 1 hour ago. Okay, so I've given you guys some time. I'm gonna get started with this. So with this question here, they're saying Trisha plays drums in the same band as Marlon. She would like to buy a new drum kit and I saved some money. Okay, what type of question is this? What type of a scenario are we talking about? We discussed this earlier. They haven't explicitly mentioned what it is, but what would you say it is? It is compounding, that's right, Amy, but I'm looking for, remember my table with the different scenarios. So this is a recurrence relation, but this was a second, you guys are steering away from what I'm trying to say. So remember we had questions where we had R as well as D. What type of scenarios were they? This is not a loan. Yeah, so Emily, what type of, yeah, very good, right? So that is an annuity with payment into account, right? This is one of those super savers, right? Because they're not withdrawing any money, right? So you guys are right, it is compounding, yes, that's correct. Geometric, correct. It's not a reducing balance, however, because we're putting money into this, right? So they're saying Trisha is investing money. So you would say V0 is gonna be equal to how much? 2,500. Vn plus 1 is going to be equal to R, which is 4.8 per annum compounded monthly. So I'd have to divide that by the 12. So I think someone's already done this for me. So I'm going to go with 1.0034 multiplied by Vn, which is my previous term. And to each of, once my interest has been calculated, I'm going to keep adding $150 to it. Okay, so that is why I said it is an annuity with payments into account. Are we all good with that then? On, we good? Fabulous. All right, so now moving on to the next, let's have a look. I think they're all quite the same. So I'm gonna keep going through the different concepts. Like I said, if we do have time at the end, we'll come back to some remaining questions because I've compartmentalized it into different style of questions. So I wanna make sure we're covering everything, and I've only got like 1 hour to go. Okay, so if we look at this question here, write down the calculations. Now, when they say show that, you actually have to show the calculations. Okay, if you just use the calculator, you're not going to get marks for them. All right, so you've got to show you're working out for these style of questions. They're saying show that Hugo's bike will be $6,000 after 2 years. So they're saying it's annual, and it's going to go down by $1,200. So that's nice and easy for us to recognize. We've got V0 is 8,400. So to find V1, first of all, that will be Vn, which would have been V0, 8,400, take away 1,200. And then you would say, well, that's going to be 7,200, right? And then you say V2 is going to be 7,200, take away the 1,200. Because to find each successive term, all we need to do is subtract 1,200 from it, right? So, and then that's when you get $6,000, and that's going to be your solution. All right, that's pretty simple. Let's have a look at this question here, right? So they toss up between having to show using the recurrence relation and having to use the nth term. So let's try and see how we would differentiate each of them. So for 2016 sample question 8, they've said, what is the annual interest rate compounding monthly for Hugo's saving account? So what are they saying? 5,000 after n months is what they've given us. If they want us to find the annual interest rate, what do we need to do, folks? To go from monthly to annual, just like we went from annual to monthly, we would divide by 12. We would multiply by how much? So this here, right, is saying if it's 0. Yeah, you'd multiply by 12, right? However, so keep in mind, when you multiply 0.004 by 12, that gives you how much? So 0.4, what am I doing? 0.48, right? 0.048, right? However, you need to multiply by 100 to get the percentage, right? So that's going to be equal to how much? 4.8%. Does everyone understand what I mean by that? Yep, everyone's comfortable with that, right? So please make sure you're doing those calculations accurately. They're asking me, what would Hugo's savings be after 12 months? Now, is it practical for me to keep doing this 12 times, like keeping on multiplying this 12 times? Guys, it's not. Okay, so we wouldn't go and do a recurrence relation for this one. We would go and use the equation that we use for nth term, right? So we know that Vn is going to be equal to, what type of a question is this? This is a, they're saying it is a compounding equation. So that would be r to the power of n multiplied by V0, in that right? So we would say Vn would have been, r is 1. I mean, I don't need to show all of these working, right? I just say V12. Sorry, why do I keep doing V's? Because I'm so used to it. Gotta change this. Sn is equal to r to the power of n multiplied by S0. So I would say S12 would be equal to 1.004 to the power of 12 multiplied by S0, which I understand is $5,000. Are we all comfortable with that? Right, so differentiating when to use recursion and when to use the nth rule is entirely up to you. It's just not practical for us to keep multiplying the same number, right? So we would say 5,024.05. They haven't really specified how many decimal places. Obviously, because this is dollars, we would leave 2 decimal places. In some cases, they will ask you to write it to the nearest dollar and things like that. So you got to watch out for that sort of question as well. Cool. Let's have a look at this question, guys. 2016 question number 18. Can I get you guys to have a go at this on your calculator? And let me know what the solution is going to be, please. All right, so we are up to page 2016, question 18. 129, 20, also pages to go. All right, has everyone had a go at that? All good, Jamin, thank you. Fabulous. So everyone's managed to get 98,467. Very good, right? So you just go and do this multiple times. So if anyone's not confident, you would, just sort of show you how that works. You just say V1 is going to be equal to 1.0025 multiplied by 100,000. And then I'd go and subtract 555, find V2. To find V2, I would take that value, whatever that answer was, and that would be my now previous value. So 1.0025 multiplied by that, and then take away the 555. Okay, and you just keep on doing that 5 times. Excellent. So let's have a look at this one here. Okay, so using recursion to write down calculations, show that. When they say show that, we always have to show them. Generally, they'll only ask you to do up until like 3, V3. So this is easy. V1 is going to be equal to 1.04 multiplied by the 15,000. Pretty simple. So we would say 1.04 multiplied by 15,000. Control enter is 15,600. V2 is going to be 1.04 multiplied by 15,600, right? And that gives me the obviously 16,224. Okay, good. All right, so looks like they're all decent questions like that. Okay, I want to do this question here because they're asking me when it would fall below a certain point. What time did we take our break? We got back here at 1:30. Did we? Yeah. Wow. All right, let's take a quick break, folks, and I'll see you guys back here in 5 minutes. So I'm not gonna put a break slide on. I'll just go here, and I'll keep this. I don't know if you guys have had a moment to have a read through these stuff. Some of the things that Annie had put together for us. Let's take 5 minutes, and I'll be back here at 2:40.
Yeah, that will never happen.
What? All because of Charlie.
Just gonna give everyone an extra minute because that was a really long session. Just if you're already here, just have a read through these. Can you hear me? Sorry. Yeah, so we would say 180 over the 3,000 multiplied by 100%. So that gives me 6%. And we've got use recursion to show that the value of the snooker table after 2 years is equal to 2640. Pretty straightforward. So you'd say V1 is going to be equal to how much? 3,000. Take away the 180. So that gives me 2820. Is that right? 2820. Yep, and then V2 is going to be equal to 2820, take away the 180, which is going to be equal to 2,640, right? Now they're asking us to calculate when it will first fall below 2,000. For this type of question, it's easier for us to go and find n, right, using the nth term. So if you remember, I said Vn is given by V0 minus n multiplied by d. Okay, and so they're asking me to solve for n. So I'd say 2,000 is equal to V0. I already know is 3,000. Minus n, I do not know. D, I know the difference is going to be 180, right? So I'd just say 180n. Okay. And to solve for n, I just go menu algebra solve. So menu algebra solve, and I would say, I mean, you could do this manually as well, but because it's further, it's not expected that you are able to do this manually. You solve for n, enter. That gives you n is approximately equal to how much? 5.5 5.55, right? So 5.6 approximately, but we can't leave it like that. We have to say after what? After 6 years, right? So that's because at 5 years, it's not below 2000, right? We would have to wait until the 6th year for it to actually fall below, sorry, what was I saying? 2000, okay? So that's cool. All right, let's have a look at this question here as well. What is this? These are all pretty simple, right? Let's have a look at this one. So 2017, guys, this is one of those questions where we've got a reducing balance loan. What did I tell you guys about reducing balance loans? Can I use the nth term formula for this? Is there an nth term formula for this type of question? We don't have one, right? Okay, so this would mean that we would have to use the recurrence relation to go and find the successive values. Okay, so can someone, well, can all of you folks try and plug this in your calculator and try and find out what your answer is going to be and let me know? So I've got, someone's already let me know what it is. Can I get a few of you guys to do it? Come on, folks. Gotta be in it to win it. So the more questions you do, the better. Yep. Fabulous. So I've got quite a few of you guys responding saying it's A. All right. So hopefully you guys understand what is happening over there. All right. So what is all of this? Let's have a look. Seems quite the same. Let's have a look at this graphing question over here. 2018 question number 20. Unit cost depreciation. Now, did I cover the note for unit cost? Let me see. Unit cost, I think we might be coming across unit cost a little bit later. Okay, I'm gonna get to unit cost in a moment. But for now, I mean, unit cost, guys, with unit cost, what do we have? We've got the same value going down, right? Right, so a certain item will decrease by a constant amount. It can't be B because it looks like it's reducing balance, right? That curve there, the value is definitely not gonna go up. It's not gonna remain the same. It's not gonna remain the same, nor is it gonna increase. It's gotta be A, okay? Nice and nice little answer there. Let's have a look. How many more questions before I get to unit cost? This is the thing with pasting it. Okay. All right, so let's do a few more of these. Let's have a look at this one here. So let's have a look at these MCQ questions because that's when I can engage you guys the most. What is the value of the regular payment added to the principal of this annuity investment? So that is going to be that difference that we keep adding. So what's that going to be? That is going to be the 500. Between the second and third years, the increase in the value of the investment is closest to. Now, this is a good question, right? So we would have to actually go and find the V2 and V3, right? Because we want to talk about the difference in the increase, right? So what's this going to be? V2 is going to be, sorry, first I got to find V1. And like I said earlier, with this style of question, unfortunately, we don't have a way to use the calculator for them. In the sense, we can't use a financial solver for them. So we would do this manually. V1 is going to be equal to 1.0034 multiplied by the 46,000 plus 500. So that's that. And V2 is going to be whatever that value is. So 1.0, oh, turned off. 1.0034 multiplied by 46,000 plus the 500. That gives me $46,656.40. So I go 1.0034 multiplied by that value there plus the 500. Okay. Oh, thank you there, Amy. So what have I got? 4731.5.03. and I've got 47,975.9. So they're asking me for the difference between the second and third year. All I had to do was just subtract this value from this here, right? So what's the answer for that one? 47975. Has anyone got that? Yep, we got C. All right, pretty simple. Okay, let's have a look at question number 20 here. What are they saying? We've got the graph, indicates that we've got a linear decay, and then it changes all of a sudden, and it's still a linear decay, right? So that's the first thing that I could see. I'd like you guys to attempt this question and let me know what the answer to this should be. Okay, so first thing is it's flat rate, right? So you can eliminate reducing. It's flat rate depreciation, yeah. Now, it can't be unit cost. Why can't it be unit cost? Because they're saying unit cost depreciation with a decrease in units used per month. It can't be a decrease because it looks like we're using more, right? The more rapid it is, that means we're using it more, which means the value is going down faster, right? So then we're tossing up between A and B. What's happening at this point? Is the depreciation rate increasing or decreasing? For the second line there, is it increasing or decreasing? It's actually increasing, right? Because it's decreasing more rapidly, which means the rate is increasing, right? So flat rate depreciation with an increase in depreciation rate after 2 months. Okay, hopefully my words there didn't confuse you. The rate here is greater than the rate there. All right, pretty simple. Which of the following recurrence relation could be used to model the value of the perpetuity investment? So I'm missing something, aren't I? Ooh. Value of a perpetuity investment. Okay, so I'm not missing anything here. So in a perpetuity, what do we say? The money doesn't run out, right? Which means the amount of money that we receive will be the amount of interest that we are incurring. Okay, so I need to check which of these is going to be the same when I multiply it by the interest rate. Does everybody understand what I mean by that? Yes, right? Which of these payments is going to be the same when I multiply my principal by the rate? So if I go and multiply 120,000 by 0.0029, that gives me a 348. So that can't be it. If I multiply 180,000, I feel like some of you guys have already done this, by 0.0047, bingo. So it gives me 846, right? Are we all comfortable with what happened there? Right, pretty straightforward concept, right? Because perpetuity, the money does not run out. It should essentially be that you're receiving the same amount as how much interest you are earning. So let's have a look. It looks quite the same. I want to look for some different questions. So, I'd like this one, please. So I've got 2019 question number 7. I'm going to give you guys a moment here to calculate this and respond to me. I would like you guys to respond to me privately. I'm not going to mention anyone's name, only because I would like everyone to have a crack at this one, right? Please note, they're not asking you for anything other than interest. All right, so think about what that means and what extra step you will have to do. And whilst you do that, I'm going to have a quick look at how much content I've got left. 2019. Okay, brilliant. And 135. Where am I up to? 2019 initially question number. Cool. Gonna have to fly. All right, brilliant. So I've got a few of you guys responding. I'll give you guys 1 more minute. So the first thing here is, right, because it's a monthly and they've determined this value for me, I can actually go and find V6 first, right? So, or T6, I should say. I'd say T6 is going to be equal to 1.0036 to the power of 6 multiplied by T0, which is 2,500, right? Now, what does that give me? Yeah, Anne, you corrected it well. That's good. So we got 1.0036 to the power of 6 multiplied by 2,500, control enter. That gives me $2,554.49, right? They're asking it for the nearest cent. So that's 2 decimal places, right? Nearest cent is, why is it 6 and not 5? Oh, whoops. What did I do wrong? Invest in the first 5 months. Callous. That's why. That's the answer to your question, Emily. It is to the power of 5. Apologies. I misread that question. 5, control enter. So that should be hang on. Let me visualize what's happening here, right? So 1.00 in the first 5 months. So let's say T0, T1, T2, T3, T4, T5, T6. Let's say, for instance, I'm not quite sure as to what's going on, all right? So this equates to 1 month. Do you understand? Because I'm going to go through the transition once. I'm going to multiply that by one. That means I've got after 1 month. This is after 2 months, after 3 months, after 4 months, and after 5 months, right? So sometimes what they might do is, actually they won't do that anymore. Sorry, that was the old curriculum. And you would see this. What I'm trying to cover is anyone that's doing matrices will understand that they sometimes give you S1 instead of S0. I hope you know what I'm trying to say here. And they try to trick you a little bit by telling you by asking you, what the value is after a certain period. And you have to consider how many transitions that we're going through. But in this case, we're looking at 5, like you guys recognize properly. So I end up with, what did I have? 2545.33, right? So you end up with interest is going to be equal to my T6, take away my T0, which is going to be $45.33. Okay, all right. Everybody okay with that? Brilliant. Let's have a look at, I think I'm going to move on to my next set of questions. So effective interest rate, right? I've got the calculator functions here. Basically, if they said the interest rate was 4.5% per annum and it was compounding monthly, to convert it into effective interest rate using the TI Inspire, you would use this method. So you go finance, interest conversion, effective interest rate. Can I get everyone to have a crack at that, please? Just make sure you know how to do that. And then on the class pad, this is what you would do. Now, when it comes to effective interest rate, what you need to remember is, are we okay with this, guys? Can I move on? Yeah. With effective interest rate, what you need to remember is a higher effective interest rate, higher, I'm going to say ER, is better, right, for an investment, right? it's worse off if it's for a loan. All right, so sometimes they ask you questions like that as well. Over here, I've got unit cost depreciation. Thank you so much, Jimin, for your time and all your support.
Thank you.
All right,
Good
have
luck,
a good
everyone.
one.
Yeah. Bye.
Peace. Bye-bye. All right, so with unit cost depreciation, you've got the purchase price, take away the scrap value, divided by the number of units used. So however often you are going to be using that device or item, and you essentially have the same style of equation as the flat rate depreciation. Okay, so you end up with the same recurrence equation as well as the nth term. What you need to remember is sometimes they'll make you do all of this stuff, and they'll say that each year they'll use it like 1,000 times. Do you understand? Right? They'll say each year they might use it like 1,000 times. In cases like that, your difference, this value, right, will change, because that'll be a new difference where you would have had to multiply your initial difference amount or your unit cost by that 1,000. Hopefully you guys understand what I mean by that. Does that make sense, guys? Sometimes they will say, you'll use it this many times a year, and then they'll ask you to set up an equation for the value after each year. If not, we will try and discover some questions that's similar to that style. So let's have a look at this. We've got, I would like you guys to have a crack at 2016 question 19, please. So where are we using rules? I'll do 2 questions and I'm going to go on to the financial solver. So what's happening with this question? Eva has $1,200 that she plans to invest for 1 year. One company offers her to pay an interest rate of 6.75% per annum compounding daily. Right? Compounding daily. So nice and easy. You can whack this on your calculator like I showed you earlier. So I've got a fair few of you guys saying D. Is that correct? Or do I need to do this? Yep. I am confident that you year 12s are able to do that using the calculator. Excellent. So looking at 2012 question number 7, what are we seeing here? Are we seeing a linear, does this appear to be linear to you guys? It's not linear, right? It's not. So it is reducing though. So it's a reducing balance scenario, right? So it can't be anything that has a 1 plus. It can't be anything like that because that is 1 plus 0.14. That would be an increasing. Now let's have a look at this, right? So we're tossing up between, what do we have? This looks like a common difference kind of scenario. Isn't that right? Right? We're not looking at nth term there. So what would you say the answer to this is? What would you say it is? Is it going to be D or E? And why would you pick E over D? So it is E. The reason that is because in D, it's showing that we have a depreciation of 86%, which means our depreciation should be like quite significant. Does that make sense? Right? It would be so small, like our line would look like something like that. Does that make sense, folks? Right? Over here, I've got a depreciation of 14%, which seems like a reasonable amount, or roughly 10% going down. So nice and easy to determine that as well. Let's do one more question before we jump into the financial solver stuff. So let's have a look at, okay, that looks quite the same. Let's do this one here, guys. Hugo is a professional bike rider. they're asking me to find out right? After how many years will this guy sell his bike, right? So when it falls to 3,600, so we have to go and find our nth term. So that is going to be 3,600. Sorry, not nth term. I need to find out n when it's going to be 3,600. So that's going to be 8,400 minus 1,200 times n. And I'm solving for n. Folks, what is n going to be? 4. So is that exactly 4? So what's that? 8,400. That is going to be, move that over, move this over to this side. Do I end up with 4,800? Yeah. So I would say 4 years, right? After 4 years. Everybody okay with that? Great. Cool. Alrighty. So we've got a unit cost question. Perfect. This is what I was looking for. They're saying, they've given us an equation. They've said the value of this bike is going to go down by 25 cents, right? Each time we use this. What is the depreciation of the bike per kilometer? Because N is in kilometers, we know that's going to be 25 cents. Pretty simple. Okay. Now, they're saying Hugo's value after 2 years is $6,000. After 2 years, the value of the bike when depreciated by unit cost method will be the same as the value of the bike when it depreciated by flat rate method. All right, this is a perfect question. I would like you guys to attempt this. So how many kilometers has the bike traveled? I'd like you guys to attempt this question because this pretty much captures everything that we've been discussing so far about unit cost. You might need the other equation. I've just zoomed in because someone wanted me to. So I'll write this here. Is that better, Emily? So have a think about what we need to do. They're saying how many kilometers has the bike traveled after 2 years, right? So we know in both methods, right? In both methods, we know our value is going to end up with 6,000, right? So we see 8,400 take away the 2,400 is going to give us a 6,000. And then over here, what we need to really understand is our value needs to go down by how much? It needs to go down by $2,400. Is that right? It needs to go down by $2,400. That's how much my D should be, right? So 2,400. But the way I would calculate D, which I showed you guys earlier, would have been 0.25 multiplied by N, because that's the number of times we would have traveled on that bike. To solve for N, that's going to be 2,400 divided by 0.25. So that's multiplying by 4, which should end up being 9,600. And what are they asking for? Kilometers. You'd write the unit as 9,600 kilometers. Well done, Raj. Everybody comfortable with that question? Are we okay to move on? Good. All right. Thank you very much. So I am going to leave these questions for you folks. We're going to jump right into some financial solver questions. I've only got 20 minutes and we've taken a break. So we'll just move through these questions here, folks. Let's have a look at 2016 question 9 here, right? I'm gonna work through these because I've only got 20 minutes to go. Okay, so we've got he's borrowed $7,500. He's going to be charged interest rate of 5.75 compounding monthly. That's all crucial information, and he's going to pay back using $430. How many repayments are required to fully repay the loan? Pretty simple. I am solving for N. Tell me who N is. I is going to be 5.76. I'd really appreciate it if you guys can plug this in your calculator and let me know what the answer is. Will save us some time. Present value is going to be a borrowing, so it's receiving money, a positive $7,500. Payment amount, money going out of your pocket because you're going to keep paying $430. That has to be a negative because it's money going from you to the bank. Your future value is going to be, ultimately with our loan, we're going to end up with a zero, right? We want to end up paying off our loan. So that's going to be a future value of zero. PPY and CPY, right? Payments per year and compounds per year. They'll both end up being a 12. So can someone tell me what N is going to be? Excellent. So I've got a 18.26, which ultimately ends up being approximately 19. What are we saying? How many repayments? So it's even 19 repayments. Fabulous. After the 5th payment, Hugo increased his monthly repayment so that the loan was fully repaid with further 7 payments, right? Now, this is a case where we are splitting the timeline, okay? Now, initially we said we would have taken 19 payments to make it, right? But what we're gonna do now is after 5 payments, we're gonna change it and we're trying to increase our payment amount. Our payment amount is gonna go up so that we wanna pay it off in 12, in a total of 12 periods, right? Now with split timeline questions, we've actually got to find the value of the loan at this point, right? We've got to find out how much the loan is going to be at the 5-month point. So what we would go and do is first, we're going to say, well, N is equal to 5 payments because we're going to make 5 payments. I is going to be equal to 5.76. Present value is going to be equal to my positive 7,500. And I've got my payment amount, which is going to be negative 430. Future value is what I'm looking for. Folks, what will my future value be, everybody? Can someone tell me, please? Okay, I've got 2 different values, Emily and Kayla. Kaya, can you just double check that for me, please? At this point, Raj, we don't want to be rounding anything, okay? At this point, we want to just basically cut and paste that value, okay? Ooh, 997. Thanks. So we've got a future value of how much? 5510.997. Now that should be a negative value because we still have to pay that. But now what I need to go and do is I need to look at this period here, right? I've got 7 months worth of pay, 7 months that I'm going to use to pay this back. I is now going to be still the same, 5.76. Present value should be this amount here, right? Because at the end of 5 payments, it's going to be not going to be a negative. Because ultimately it's assuming that we still have received that loan, okay? So 5510.997, whatever. Payment amount is what we want to find out because ultimately we want to increase our payment. Future value is going to end up being a 0. PPY and CPY will both end up being 12. So how much is my payment? I've got $802.47. That will be a negative. However, you would have to write a sentence, right? Sorry, habit of using short form. You would say payment equals $802.47. Guys, you have to write this to get full marks. You cannot leave it like this, okay? If you leave it like that, you're not going to get full marks, okay? So make sure you please go and write that sentence saying payment equals so-and-so, all right? The negative does not mean anything to the assessor. What is the value of the final payment required to ensure the loan is fully repaid after 12 repayments? Okay, well, we just said after those 7 payments that we're going to end up paying off our loan. So what is this talking about? Now, what we need to understand is because when we do our calculations, we're going to do some form of rounding. What happens is when you get to that point where you're at that final payment amount, you will either have a positive value or a negative value, okay? So what we need to remember is If for a loan, okay, if for a loan you've got a positive future value, right? That means you have overpaid. Okay, that means you have overpaid the loan, because ultimately that means that you're supposed to be receiving that money. If it's a loan and you've got a negative future value, that means you have underpaid the loan. Do you understand what I mean by that? Right? That will mean that you've underpaid the loan. Now, if you have overpaid, that means to avoid doing that, your final payment amount should be your usual payment amount minus that future value. Do you understand? Minus whatever the future value you would have had. If you're going to be underpaid, your final payment will be your usual payment amount plus that future value, right? Okay, so if you have a negative value, you would have to add that value, not put a negative, all right? So let's have a look at this question. What's the value of the final payment required to ensure the loan is fully repaid after 12 repayments? So that means we have to go and find the future value at the end of those 7 payments, right? So I'm going to say, well, n is going to be equal to a 7, right? I is going to be equal to a 5.76. Present value is going to be equal to 5510.997. Payment, I know, apologies, can you guys see that? Minus 802.47. Future value is what I'm looking for. And PPY and CPY would be equal to a 12. Now, can someone tell me how much this amount is going to be, the future value at this point? Excellent. So I've got here that we are going to end up with a future value of negative 0.025, right? Now, what do we notice? My future value ends up, my future value here is a negative, which means I said for a loan, right? That means I have underpaid. That means my final payment has to be my usual payment amount plus that future value, right? So we would go and say, well, final payment, therefore final payment is going to be equal to $802.47 plus 0.025. Okay, right? So I'd go and say, well, that's going to be equal to 802.47 plus 0.025, control enter. That gives me $802.495, like that. However, I know that because this is decimals, this is dollars and cents, I would say that's going to be $802.50. All right, are we okay with that, guys? Feeling good? Yeah. All right, makes sense, everybody? Brilliant. We probably have time for about 2 more questions before I talk about a few tips. So what we might do is let's do some more recent questions. Let's have a look at some 2019 questions, right? Okay, let's have a look at these 2 questions here. So NHT, so that's Northern Hemisphere exams. Can I get you guys to take 2 minutes and respond to me with answers to both of these questions, please? Oh, Mahira, sorry. I'll go to the top. Where are you? What are we missing? This bit here? Does that help? Can you take a screen grab of that, please, so I can... Yeah, fabulous, thank you. So where were we? 2019. I'd like you guys to respond to me with the solution to both of these questions. Aaron, can you please make sure you fill in that survey for us before you head off, if that's all right? I will send you that survey. Thank you. Fabulous. All right, how are we looking, guys? Yep, Emily, I'll send that. Okay, thank you. All right, so I've got A over here for question 22. So what we would have had to do was we would have had to find the future value after 4 months, right? FV after FV at n equals 4, and then go that future value to find the interest amount. That would have been future value at 4, take away present value of 12,000. So hopefully you guys managed that. Before we wrap things up, I want to go, has anyone done question 23 as well? Emily? So getting there, it's quite similar to what we've already done. Okay, so I am gonna jump right into that very last section of financial maths where we have to use the table. So I've got some notes here for you guys. What you need to remember is the interest amount or the interest earned is gonna be your rate per period multiplied by the previous balance. So when I say, let me use a different color for that, right? The previous balance. So for this one, right, we would use the previous balance would be, so to get this interest amount here, you would have used the previous balance, which is the green, and multiplied by the percentage, right? Then the principal reduction, let's use orange, reduction in principal, that value there would end up being your payment made, take away your interest earned. Okay, nice and simple. So I've got the equations there for you. And to find your new balance, right? To find your new balance. So for instance, the way I would find this is that would be this value here, take away the reduction in principal. So that would be the new value that I would get for this one here. Okay, so please make sure you guys trial some of these. For 23, I've got Emily saying it is 23B, which is fantastic. Guys, please try some of these questions. Now, before you head off, I would really, really appreciate it if you guys could go and fill out this survey for us. That's obviously, you know, an opportunity for us to realize what we've done right, what are some of the things that we could have done a little bit better. Please keep in mind, I have not completed everything that you need to know for further. I've only managed to really quickly go through the core, so data stuff, as well as the financial maths and recursion. Even then, I would have loved to have had more time. Obviously, you could have seen that we were pressed for time, so I tried to, you know, incorporate as much as possible. Please go and look at all the notes that I've given you and attempt the questions, right? Because this is relevant to each of the topics. And all your solutions will be available on the Vika website. So hopefully you guys have, you know, already accessed it a couple of times. If you are in need of any practice exams, Annie's got a whole bunch of them, which I've given to her. So feel free to reach out to that. Henry, where do we download the notes document again? What do you mean by notes document? Is it the one that we've been writing on? If that's what you're referring to, Henry, I will send the link to Andrew and the team, so they will have that uploaded for you, so you can review all the notes. But look, guys, all the very best with your exams. A couple of key things to remember: do not make any careless mistakes, right? So make sure you are double checking, especially things like your units, your decimal places. Make sure you're labeling your data variables on your calculator accurately. So you've got plenty of ways to go and double check your solutions, right? So you don't have to keep deleting your tabs. Khan, you were asking practice exams. Annie has a whole bunch of company practice exams with her, so she'd be happy to share that with you. So just get in touch with her. She'd be able to help you out with that. But yeah, thanks so much for joining me today, and all the very best. Reach out if you guys have any questions. Thank you, Jeremy. Have a good one. Thank you, Amy. All the best. All the best, everyone.